Hello, friends, and welcome back to The Snoozy Scientist, where we gently explore the mysteries of our world, one sleepy yawn at a time. Whether you're listening from your bed, curled up in a warm nest of blankets, or drifting through that quiet space where thoughts begin to blur, you're exactly where you need to be. Tonight, we're setting sail into a part of the ocean where logic loosens its grip, where navigation falters, radios go silent, and time itself sometimes forgets to move forward. They call it the Bermuda Triangle, a place that's been named many things: a maritime graveyard, a supernatural riddle, a zone of silence. Over the last 100 years, more than 1,000 ships and aircraft have vanished within this quiet triangle, stretching from Miami to Bermuda to Puerto Rico. Some disappeared in clear weather, some left behind no distress call, and some were never found at all. For decades, these stories lived somewhere between legend and coincidence, until recently, because now, in the hush of modern science, something new is surfacing. Scientists, using cutting edge ocean floor mapping, have made discoveries that challenge everything we thought we knew about this place. Recent expeditions using deep sea sonar have revealed unexpected trenches, seismic scars, and oddly symmetrical ridges hidden far beneath the waves. Formations that suggest the ocean floor here may be more volatile and more mysterious than we ever imagined. Tonight, we'll drift slowly, patiently, through the discoveries scientists have only just begun to uncover, and the secrets the sea may never fully give up. If you enjoy videos like this, slow, soothing, and quietly packed with scientific wonder, it would mean the world to me if you gave this one a gentle like and maybe subscribed. It helps more curious minds like you find their way to this peaceful little corner of the internet. And if you're still awake enough to type, let me know in the comments where you're listening from and what time it is where you are. It's always nice to see how far these sleepy videos reach across the globe. Now, take a deep breath, close your eyes, let your shoulders soften, and let's begin. It began on a clear December afternoon in 1945. The air above Florida's coastline was calm. The water below shimmered in late sunlight. At 2:10 p.m., 5 Navy Avenger torpedo bombers lifted off from Fort Lauderdale on what should have been a routine training mission, a simple navigation exercise known as Flight 19. The planes were sturdy, reliable machines. The pilots were young, but trained. They were to fly east, then north, then back west, a triangle-shaped loop lasting just over 2 hours. Nothing about the day suggested it would end in mystery, but less than 2 hours into the flight, something began to unravel. The first sign was confusion, not from weather or engine failure, but from the pilots themselves. A routine radio check turned into a growing note of concern, then frustration, then panic. The leader of the mission, Lieutenant Charles Taylor, sounded increasingly disoriented. In one transmission, he reported, "We don't know where we are. We must have gotten lost after the last turn." Moments later, he added something stranger. "Everything looks wrong. Even the ocean doesn't look as it should." Compasses, he said, were no longer working. They spun without direction or pointed in conflicting paths. The sun, still visible, should have helped them reorient. But Taylor insisted the coastline below didn't make sense, as if geography itself had shifted. The other pilots echoed his confusion. One suggested flying west, another argued east. They couldn't agree. Over the next hour, the radio messages became more erratic as the planes burned through fuel, unable to find land, unable to agree on where they even were. Then, silence. At 6:20 p.m., all contact ceased. The Navy immediately launched a rescue operation, A search plane with 13 crew members was dispatched within minutes, but that plane, a massive PBM Mariner, also vanished. No distress call, no wreckage, no survivors. In less than a day, 6 aircraft and 27 men had vanished over the Atlantic. The incident became national news almost instantly. For many, it was the moment the Bermuda Triangle transformed from rumor into legend. In the official investigation that followed, no firm explanation was found. The weather, while somewhat stormy later in the day, didn't match the severity of the disappearance. There was no evidence of mechanical failure. The Navy's final report listed the cause of the loss as unknown, but over the years, some began to speculate. What if something more than pilot error had occurred? What if they'd entered a zone where instruments didn't behave the way they were supposed to, where directions meant little and the sky and sea became a maze with no clear exit? And then there was the matter of their voices. The panic in Taylor's final messages wasn't just about losing track of location, it felt deeper, as if something unseen had begun to surround them, something they couldn't name. For decades, Flight 19 remained one of the most iconic mysteries of the Bermuda Triangle, and for just as long, no sign of the planes was ever found. No fuselage, no floating wreckage. It was as if the sky had swallowed them. That is, until recently. In the last few years, marine archaeologists equipped with high-resolution sonar and remotely operated submersibles began scanning the seafloor near the suspected crash zone, and in 2020, several pieces of aircraft wreckage were located off the Florida coast, twisted metal fragments lying deep under layers of sand and silt. Some of the recovered parts were confirmed to be from Avenger bombers. But here's the catch. While they matched the type flown by Flight 19, they couldn't all be positively identified as those planes. Other Avengers had crashed in the region during World War II. The debris field was confusing, overlapping, and incomplete. Still, the discovery marked a turning point. For the first time, physical evidence hinted at the final resting place of the lost flight. But the mystery wasn't solved, not fully. Not all 5 planes were accounted for. Some still remain hidden, perhaps scattered, perhaps sunken into deeper unmapped trenches, perhaps pulled somewhere farther than we've yet looked. And so the question lingers. How could 5 trained crews become so completely disoriented in such a short time? Why did their compasses spin and their confidence collapse all at once? And why did the search plane sent to rescue them vanish in exactly the same space? Some blame pilot error, others unexpected weather. But there's something about the story, the speed of the breakdown, the eeriness of the last words, the echo of static that followed, that leaves room for wonder. Because when we think of disappearances, we expect a cause, a reason, a sound. But here, all that remains is silence, and the sea, as always, says nothing. Not every disappearance happens in the sky. Some stories begin on the water and then simply stop. No explosion, no call for help, just an empty horizon where a ship once was. The SS Cotopaxi was a steam-powered cargo vessel, 253 feet long, with a steel hull and 2 sturdy masts. On November 29, 1925, it left the port of Charleston, South Carolina, carrying a crew of 32 men and a load of coal bound for Havana, Cuba. It never arrived. For nearly 100 years, the Cotopaxi existed only in whispers and speculation. It had vanished so thoroughly, so completely, that it became a kind of ghost ship, an early chapter in the growing mystery of the Bermuda Triangle. And the timing only fueled the legend. The 1920s were an era when transatlantic communication was still new, radar didn't exist, and storms often rolled in without warning. When the Cotopaxi failed to reach Havana, there were no clues to explain why. No floating debris, no bodies, no radio signals. The ship was officially declared lost at sea, but unofficially, it became something else. Stories began to circle. Some claimed the Cotopaxi had been pulled into a sudden whirlpool. Others believed it was taken by strange weather or swallowed by a hidden force under the water. The triangle myth hadn't yet been named, but this disappearance helped build it. For decades, people searched. Expeditions combed the sea with sonar and hope, but nothing surfaced. It was as if the Cotopaxi had been erased. Then, almost a century later, in the spring of 2020, something changed. A team of marine researchers, led by Michael Barnett, a diver and shipwreck hunter, began analyzing an unidentified wreck lying about 35 miles off the coast of St. Augustine, Florida. It had been discovered years earlier, but remained unconfirmed, just another rusting skeleton on the ocean floor. But this time, something clicked. The team matched the dimensions of the wreck to historical blueprints of the Cotopaxi. They examined construction features, cargo hatches, and rivet patterns. They even found artifacts, valves, and pipes stamped with the maker's name from the same era. The evidence became impossible to ignore. They had found the SS Cotopaxi. It wasn't near Cuba. It wasn't hidden in deep trenches. It was far north of its projected route, resting in relatively shallow water. The discovery made headlines across the world. But it also raised new questions. Why was the Cotopaxi so far off course? What had driven it north toward Florida instead of south toward Havana? And why hadn't it been located sooner? Researchers believe the answer lies in the sea itself. The region near St. Augustine is heavily influenced by the Gulf Stream, one of the fastest and most powerful ocean currents on Earth. It can push a drifting vessel hundreds of miles over time, altering its course in ways even modern sailors struggle to predict. It's possible the Cotopaxi encountered mechanical trouble or rough seas, perhaps a sudden squall, or flooding in the hold, and began to drift. If the crew lost control, the Gulf Stream may have done the rest, pulling the vessel far from its intended path and eventually grounding it on a submerged sandbank. And here's where things become even more curious. The Cotopaxi wasn't the only vessel to have ended up where it shouldn't be. Over the years, dozens of ships lost in the western Atlantic have been found in places completely outside their last known course. Some appear to have looped in strange arcs. Others seem to have reversed direction before sinking. It's as if the ocean sometimes plays tricks with its dead. New theories began to form. Perhaps there are microcurrents, small spiraling flows beneath the surface that interact with the Gulf Stream and twist the path of sinking vessels. Some scientists suggest the seafloor's subtle ridges and valleys create localized pressure zones, pulling wrecks along invisible trails. These underwater conveyor belts may carry a ship farther than previously thought, sometimes for days after it disappears. The Cotopaxi's rediscovery was not just the end of a mystery, it was the beginning of a pattern. It told researchers that the Bermuda Triangle may not be about sudden vanishings into nothing. It may be about distance, about how far a vessel can travel after it loses power, after it falls silent, about how misleading our assumptions have been, even with maps and models. And if the Cotopaxi ended up somewhere unexpected, how many others have too? The answer may lie just beneath us, hidden in shallows mistaken for deep, in wrecks covered by silt, in shadows that look like rocks until we look more closely. The ocean doesn't always bury its secrets far below. Sometimes they're right there, just waiting to be recognized for what they are. And as researchers begin scanning the seafloor with newer, sharper instruments, more ships are beginning to rise from the quiet, not in movement, but in memory, which leads us deeper into the next question. What else is under there that we thought was gone? The ocean does not stay still. Even when it looks calm on the surface, it is always shifting beneath, beyond, and deep inside itself. For years, the Bermuda Triangle has been imagined as a fixed shape, a static zone drawn by lines between Miami, Bermuda, and Puerto Rico, as if mystery could be contained within a neat triangle of water. But what if those boundaries were never permanent? What if the true reach of the triangle is stretching inch by inch, wave by wave? Researchers analyzing marine incident patterns have begun to notice something subtle, a drift, not of ships or planes, but of the incidents themselves. In recent years, some disappearances, strange weather events, and mechanical failures have been reported outside the traditional triangle. Not far, but far enough to raise eyebrows. A freighter veers off course near the southern tip of the Bahamas. A private plane vanishes somewhere near the northern coast of Venezuela. An autonomous drone loses all telemetry signals while surveying waters east of the Windward Islands. Each of these alone might be nothing, a storm, a malfunction, a technical glitch. But together, over time, they begin to paint a different picture, one that suggests the mystery is moving. Some researchers now wonder if we've misunderstood the nature of the Bermuda Triangle altogether, that perhaps it was never a single spot, but a fluid phenomenon anchored to no fixed geography, something dynamic, expanding, evolving. Data analysts from marine safety boards have charted incident maps stretching back decades. They've layered old flight paths with new search zones, overlaid shipping routes with updated current models, and in doing so, they've started to see a quiet migration, a gentle slide of anomalies to the southeast, reaching deeper into the Caribbean and curling along the edge of the South Atlantic Ridge. What could be causing this subtle shift? One possible answer lies far beneath the water in the slow, grinding movements of the tectonic plates. The Atlantic Ocean is bordered by massive geological forces, constantly pulling apart and pressing together. The Caribbean Plate, in particular, is a zone of activity where the crust moves just a few centimeters each year, barely noticeable to us, but enough to gradually reshape entire coastlines over time. This tectonic tension doesn't just affect land, it alters ocean depth, tilts fault lines, and can even trigger minor underwater quakes. These small events may be invisible to the eye, but can ripple through deep water, disturbing currents, pressurizing pockets of gas, and subtly reshaping how water moves through the region. Some oceanographers believe this slow motion stress may be warping the local magnetic field, not enough to spin a compass wildly, but enough to interfere with high sensitivity instruments. GPS data can wobble, autopilot systems can drift, and in the open ocean, even a 1 degree deviation can mean the difference between safety and vanishing. Then there's the issue of rising sea levels, something we often think of in terms of coastlines and cities, but rarely in terms of ocean structure. As polar ice melts and the oceans swell, water doesn't just rise, it spreads, infiltrating low-lying trenches, overtopping coral formations, and expanding the ocean's horizontal reach. Shallow banks become deeper, warm surface waters flow into cooler zones, storm tracks shift ever so slightly. The Bermuda Triangle has always been vulnerable to sudden storms, but new atmospheric models suggest that storm genesis points, the places where these systems are born, are creeping further south. Areas once thought marginal now see more lightning strikes, higher winds, and rapid pressure drops. Even the currents have changed. The loop current, which feeds into the Gulf Stream, now swells slightly wider during certain months of the year. It wraps deeper into the Caribbean, pulling heat from places that once sat outside its influence. This change doesn't just affect climate, it alters how fast and where wreckage might drift if something goes wrong. And this matters because many of the triangle's mysteries rely not just on what disappears, but on what never returns. No debris, no signal, no explanation. If the area of fast moving currents and unpredictable pressure zones is expanding, then so too is the zone in which things might vanish without trace. Even insurance companies, not known for chasing ghost stories, have begun to revise their risk assessments. Shipping lanes once deemed outside the triangle's edge are now flagged for closer monitoring. Flight corridors are reevaluated, not because of fear, but because of patterns. Not all disappearances fit into neat boxes. Some defy repetition. But when incidents start drifting outward, when danger stops respecting boundaries, we're forced to reconsider the maps we trust. Because maybe the mystery was never in the triangle. Maybe it's been following the water all along. And as we follow it further south, into deeper trenches and warmer currents, we begin to approach new questions. One's not about where the triangle was, but where it might be going. The deeper you go, the less the light understands where it's going. Sunlight gives up after just a few hundred feet. And beyond that, the ocean falls into darkness, slow, cold, and quiet. For most of human history, we've looked down at the sea and seen only reflection. But now, for the first time, we're beginning to see the shape of what lies beneath. With the help of modern bathymetric sonar, an advanced form of underwater mapping, scientists have been tracing the ocean floor like never before. Instead of blurry outlines and depth guesses, we now have detailed 3D renderings, sweeping trenches, sharp ridges, sunken plateaus, and cavernous hollows. What once seemed flat and featureless is now a vast, rugged landscape, and the area known as the Bermuda Triangle, it's full of surprises. When researchers first aimed their sonar beams into the depths between Florida, Bermuda, and the Caribbean, they expected smooth seabeds and predictable slopes. What they found instead were sharp drop-offs, buried cliffs, and deep channels carved into the ocean floor, like old scars in soft stone. Some of these formations are so steep and jagged that large ships could disappear into them without leaving so much as a ripple on the surface. But the most alarming features aren't the trenches themselves. It's what they show signs of having done. In several places across the region, the mapped seafloor displays strange, chaotic patterns. Sloped fields of debris, long streaks of sediment trailing down underwater valleys, and mounds of displaced material scattered across vast distances. These aren't random. They're signs of turbidity currents, underwater landslides caused when large volumes of loose sediment suddenly collapse and rush downhill through the sea. They move fast, and when they move, they carry everything with them. Imagine a wall of sand and silt breaking loose from a steep underwater slope. Gravity pulls it downward. It builds speed as it falls, gaining force, becoming heavier and denser as it drags seawater into its tumbling flow. Now imagine a ship or a plane that's recently crashed, lying quietly near that slope. And then it's gone, not because of impact, but because the seabed itself decided to move. Turbidity currents are powerful enough to snap cables, bury structures under hundreds of feet of debris, and erase almost any trace of what was there. They leave no floating wreckage, no oil slick, just silence and a floor that looks slightly more uneven than before. Some of the most striking sonar images in recent years show exactly this kind of disruption in parts of the triangle. Places where the ocean floor isn't smooth but jagged and freshly disturbed, where sediment has piled in unnatural ridges, where objects larger than cars seem to be embedded sideways in silt, half buried by something that clearly wasn't there before. In one section near the northern Bahamas, sonar data revealed a series of parallel gouges, as if something large had scraped across the bottom and been dragged along by a force far greater than its own weight. Scientists believe this could be the aftermath of a turbidity event that occurred decades ago, possibly triggered by an earthquake or even a strong storm that rattled the seafloor. And these aren't just isolated cases. The entire region shows evidence of frequent, low level activity, as if the ground beneath the triangle is in a constant state of subtle rearrangement. Not enough to make headlines, but enough to hide things. It's important to remember that when a ship or plane disappears in the ocean, it doesn't stay visible for long. Even a large metal structure can become invisible once it settles into sediment. And if that sediment shifts as it does in these landslides, it can bury entire vessels in hours. Sonar might pass over the area a dozen times and see nothing. This could explain why so many wrecks, even ones lost in modern times with GPS coordinates, are still unfound. It's not because they vanished into another dimension, it's because they sank into a landscape that is always changing. And it's not just the floor that shifts, but the story. As more of the triangle is mapped in finer and finer detail, scientists are realizing they've barely scratched the surface. There are submerged cave systems still being explored, unexpected pockets of low pressure that may alter how objects fall, and a whole network of trenches that seem to bend and break in patterns we're only beginning to understand. What was once imagined as a flat, endless blue is now revealed to be a vast, rugged terrain full of crevices, collapses, and deep places that don't like to give things back. And somewhere in that darkness, the next part of the mystery waits. The sea is often imagined as gentle, endless, and soothing, but every so often it stands up, not gradually, not politely, but all at once. And when it does, it rises in silence, without warning, without pattern, and without mercy. For a long time, rogue waves were treated more like sailors' tales than scientific fact. Stories passed from one weathered hand to another, tales of massive walls of water that seemed to appear out of nowhere, towering above the horizon, crashing down with impossible force, then disappearing as if they had never been there at all. These waves didn't fit with traditional ocean theory. They were too high, too fast, too sudden, and so for decades they were dismissed, folded into the same file as sea monsters and ghost ships. But all of that began to change in 1995 when a rogue wave measuring over 85 feet tall struck the Draupner oil platform in the North Sea. It was recorded by sensors, photographed and confirmed beyond doubt. Suddenly, the impossible had data behind it. Since then, scientists have been working to understand how such waves form, and now, in 2025, they may have found their most important clue yet. At the University of Southampton, a team led by Dr. Simon Boxall developed a new model to simulate the complex interactions between weather, currents, and sea topography. Using satellite data, real-time ocean monitoring, and machine learning algorithms, they created a high-resolution model of the Atlantic and ran it forward under different storm conditions. The result? They identified a specific set of ingredients that can cause rogue waves to form, and these ingredients frequently come together in the Bermuda Triangle. It's all about weather convergence when two or more weather systems collide in just the right way. In most oceans, when a storm moves in, the waves roll in one direction, guided by the wind. But in certain conditions, multiple storms can create waves moving in different directions, from different angles, all meeting at once. When those waves combine, not gently, but suddenly, the energy doesn't cancel out. It stacks. One wave climbs on top of another, and then another, until it forms a vertical wall of water that rises far above anything predicted by standard forecasting. These rogue waves can reach over 100 feet tall, taller than a 10-story building, and they don't roll like tsunamis. They slam downward, hard and fast, with no warning, often in the middle of what appears to be otherwise manageable seas. Dr. Boxall's 2025 study concluded that the unique combination of the Gulf Stream, seafloor geometry, and frequent storm activity in the Bermuda Triangle makes it one of the world's most likely places for these deadly waves to occur. And crucially, it's not just during hurricanes. Rogue waves don't need cyclones or dramatic wind speeds. They can form on relatively calm days when smaller storm systems or pressure differences intersect just right, which might explain why so many disappearances in the triangle happened in good weather. A rogue wave doesn't care about the sky, it forms below it. The terrifying part isn't just the height, it's the speed. These waves rise in seconds and collapse just as fast, giving a ship little to no time to react. For smaller vessels, a rogue wave is devastating. It can crack hulls, flood compartments, or simply roll a ship completely upside down. Even larger ships aren't immune. Some freighters have been found split in two, their decks buckled inward, signs of a force that struck from above, not below. And for aircraft, the implications are just as troubling. If a plane is flying low over the water during descent or storm diversion and encounters the spray column or upward air thrust of a rogue wave, instruments may spike, stall warnings may trigger, and control can be lost in the crucial moments before correction is possible. Dr. Boxall's team mapped where these rogue waves are most likely to form based on historical conditions. A significant portion of them landed right in the heart of the Bermuda Triangle's busiest corridors, areas where both ships and planes have disappeared without explanation. Until now, those vanishings seemed random, but viewed through this new lens, they may simply be the work of a rare but real monster, one that lives not in myth but in mathematics. And it raises new questions, not about what happened to the missing, but how many more we still don't understand. Because if a rogue wave can rise in 10 seconds and vanish in 15, leaving no evidence, no trail, and no reason to suspect it ever existed, then how many mysteries have simply been washed away? The answer may not lie in the sky, but in the next moment, the sea decides to rise without warning. Some forces in the ocean are loud, sudden, violent, but others are quiet, slow, and constant, like a breath you don't notice until it's gone. One of the most powerful of these forces is something almost invisible. It has no sharp edges, no sound, yet it moves with more strength than nearly anything else on Earth. It's called the Gulf Stream, a massive river of warm water flowing through the Atlantic Ocean. And it moves through the Bermuda Triangle like a silent conveyor belt, always in motion, always pulling. This current begins in the Gulf of Mexico, squeezes between Florida and Cuba, then arcs up the eastern coast of the United States before curling across the ocean toward Europe. It's not just a drift, it's fast. In some places, the Gulf Stream moves at over 5.6 miles per hour, which might sound gentle until you realize that's faster than many ocean-going ships. For centuries, sailors knew of its presence. They felt the pull beneath their hulls, watched debris float faster than expected, noticed changes in water color and temperature, but they couldn't see it. And because they couldn't see it, they underestimated what it could do. Now, thanks to new current tracking satellites, we can watch the Gulf Stream from above, not as a flat blue ribbon, but as a writhing living system full of twists, eddies, and unexpected surges. And what we're finding is unnerving. This isn't a smooth, predictable stream. It pulses, speeding up or slowing down, depending on season, wind, atmospheric pressure, and underwater geography. It breaks off into whirlpools called eddies that can spin like slow hurricanes, trapping anything caught inside. And in the Bermuda Triangle, these eddies and branches form an underwater maze, one that can take a ship, a piece of wreckage, or even a floating body, and pull it far from where it was lost. Imagine a plane goes down in the middle of the triangle. The impact site is logged. Search teams arrive within hours, but the current has already moved everything. The wreckage, the fuel slick, the locator beacon. Some pieces drift northeast, others spiral south. By the time the search begins, it's already chasing ghosts. This could explain why so many disappearances in the region result in no debris. Why ships and planes seem to vanish without a trace, even when rescue efforts begin almost immediately. It's not that they leave no trace, it's that the trace doesn't stay where it's supposed to be. The Gulf Stream also runs deeper than many realize. It doesn't just push things along the surface, it has layers, cold water beneath warm, flowing in different directions at different speeds. Objects that sink don't simply fall to the seafloor in a straight line. They tumble through a vertical conveyor, drifting sideways as they descend, carried by hidden fingers of current, and even if something makes it to the bottom, it doesn't always stay there. Eddies can reach down and stir the seafloor, lifting silt and small debris and pulling them back into circulation. Some oceanographers compare it to a giant hand, brushing across the ocean basin again and again, erasing evidence, redistributing wreckage, painting over clues. It also plays tricks with temperature. Because the Gulf Stream carries warm tropical water into cooler zones, it creates patches of ocean that appear calm but are full of thermal instability. These temperature shifts can confuse radar systems, disrupt pressure sensors, and affect visibility from both satellites and aircraft. A search plane scanning for debris may pass over the right spot and see nothing, and then there's the human factor. Pilots and captains rely on wind models, GPS drift estimates, and historical current charts to calculate likely crash zones. But if the Gulf Stream has sped up, or split, or dipped farther south that week, those calculations fall apart. Search efforts are focused in the wrong direction, and the sea keeps its secret. In 2024, a series of updated satellite models revealed that sections of the Gulf Stream were accelerating during certain months, sometimes by as much as 20%, depending on storm activity and melting polar ice. That acceleration isn't steady. It comes in pulses, like the heartbeat of something enormous, hidden just beneath the waves. And these pulses could be responsible for misleading search teams or causing wreckage to wash up thousands of miles from its point of origin, or not wash up at all. Which brings us back to the mystery. Not everything that disappears in the Bermuda Triangle is swallowed whole. Some of it is simply moved, rearranged, scattered like puzzle pieces in an invisible wind. And when the sea decides to keep those pieces apart, the picture never comes together again. Which makes the next question even more difficult. When the ocean steals the evidence, how do we ever really know what happened? The ocean is not the only force that moves without warning. Sometimes the sky itself turns silent and strange, a ceiling of calm just moments before it opens. As we rise gently above the waves, up into the layers where ships become specks and cloud shadows stretch for miles, we find another kind of danger, one that doesn't roar like thunder or flash like lightning, one that's quiet, invisible, and terrifying. In the Bermuda Triangle, there are stories of planes that vanish mid-flight. No mechanical distress, no calls for help, just silence, followed by wreckage days later, or nothing at all. For a long time, these disappearances were blamed on navigation errors or sudden engine failure. But now, scientists are turning their attention to something far harder to detect, something that's not a storm, but acts like one. They're called microbursts, sudden violent downdrafts of air that explode downward from the sky, crashing into the surface like an invisible hammer. These events can happen beneath ordinary-looking clouds. From a distance, the sky appears calm, maybe a little gray, a little heavy, but nothing serious. But inside the cloud, something begins to stir. Cool air from higher altitudes starts to fall, dragged down by evaporating rain or a quick temperature drop. As it sinks, it picks up speed, fast, and by the time it hits the lower atmosphere, that air is moving at hurricane force straight down. When it slams into the sea or land, it doesn't just stop, it spreads out, sending horizontal winds outward in all directions, like ripples from a dropped stone, only much stronger. For planes, especially smaller or descending aircraft, these vertical wind blasts are incredibly dangerous. A sudden microburst can push a plane down faster than its engines can lift it, robbing it of lift in seconds. And in 2024, weather radar logs confirmed what pilots and meteorologists had long suspected. Dozens of these microbursts, many of them near invisible, occurred in and around the Bermuda Triangle over the course of just one storm season. Some were brief, lasting only 30 seconds, others stretched for several miles, changing direction and intensity as they fell. But nearly all shared a troubling pattern. They struck low flying aircraft right as they were changing altitude. And it's not just the force of the air that makes them dangerous, it's the confusion they cause in the cockpit. Pilots flying through a microburst often report instrument failure or erratic readings. Airspeed indicators spike or drop without warning. Altimeters jump suddenly. Artificial horizons tilt, showing level flight when the nose is already tipping downward. In that moment, the sky becomes untrustworthy. The controls feel wrong. The view outside, if there is one, might show only gray, and in seconds, a stable flight becomes a desperate struggle. Even experienced crews can be overwhelmed. There's no turbulence to warn them, no radar alert, only the instinct to pull up, and sometimes that's not enough. In one case, a light aircraft flying near the southern edge of the triangle dropped over 2,000 feet in under 10 seconds after entering a column of unstable air. The pilot survived, shaken, but alive. He later described it as flying into a vacuum. No resistance, no warning, just sudden descent, like falling through air that had forgotten how to hold him up. Larger planes aren't immune either. In the 1990s, a passenger jet over the Caribbean encountered a powerful downdraft while making its final approach. The plane lost altitude sharply and landed hard, fortunately without casualties, but the incident matched the signature of a microburst. Now, with better technology, we can spot these events more clearly, but even the best radar systems can't always detect them in time. Microbursts form too quickly, they last too briefly, and in regions like the Bermuda Triangle, where heat, humidity, and changing wind layers are always present, the atmosphere is perfectly primed for their formation. What makes it worse is that these bursts often form below radar coverage. By the time they're visible, they've already done their work, pushing a plane down, flipping a vessel, or sending spray hundreds of feet into the air. And because they leave behind no sound, no trail, and no damage above the clouds, they're almost never suspected until now. With newer radar logs and pattern recognition models from 2024, researchers are finally starting to track these incidents more closely. And what they're finding is that the triangle doesn't just swallow planes, it ambushes them, with gusts so sudden they feel like the sky itself has turned against them. And so we add another layer to the mystery, not below the waves, but high above them, where the air can seem calm, but isn't, where invisible hands reach down, not to guide, but to pull. And somewhere between those layers, between the pressure of the sea and the weight of the air, we begin to understand how fragile our presence in this world really is. High above the ocean, wind can knock a plane from the sky, and deep below, currents can carry a ship far from where it was lost. But in between, just under the surface of what we understand, lies another mystery. It isn't loud, it doesn't move, but it pulls quietly, constantly, and when it changes, even slightly, everything we trust can fall apart. It's the Earth's magnetic field, the invisible shield that surrounds our planet, guiding birds, satellites, and compasses. It's steady until it's not. For as long as humans have crossed open water, they've relied on the compass, a simple needle, suspended and sensitive, always pointing toward magnetic north. But in the Bermuda Triangle, even this most basic tool has a tendency to misbehave. Some pilots flying through the region have reported sudden compass failure. Not a slow drift or a weak reading, but a complete spin, the needle turning in circles, pointing nowhere, or worse, pointing the wrong way with full confidence. These moments don't last long. Sometimes it's just a minute, sometimes less. But in a cockpit or on a ship's bridge, a minute of misdirection is enough. And the strangest part, these compass spins often happen nowhere near the Earth's magnetic poles, places where such anomalies might be expected. The Bermuda Triangle isn't especially close to the North Magnetic Pole. It isn't a global magnetic hotspot, and yet it has a history of confused instruments that stretches back long before digital sensors and modern avionics. Early navigators wrote about compass roses that danced and needles with minds of their own. Modern flight crews speak in technical terms: magnetic deviation, instrument interference, system fault. But the story remains the same. The compass doesn't always play by the rules in this part of the world. Scientists have offered explanations over the years. The most common one is magnetic declination, the natural difference between true geographic north and the direction a compass points, which is magnetic north. This variation changes depending on where you are on the planet, and over time, Earth's magnetic poles themselves slowly drift. In some regions, especially around the triangle, this declination can be small enough that it's often ignored in casual navigation, but just large enough to matter in high-speed flight or stormy conditions. A few degrees off course over many miles can lead a vessel far from its intended path, but there's a problem with this explanation. Declination is steady, predictable. It doesn't spin a compass. It doesn't come and go. And yet, in several reported cases, instrument data from planes and boats shows brief magnetic spikes, sudden sharp changes in magnetic readings that disappear as quickly as they arrive. When researchers try to recreate the conditions using simulators or models, the readings don't match. They can't be reproduced. Some suggest these are equipment malfunctions. Others blame atmospheric interference or solar flares. But in most incidents, the skies were clear. Solar activity was normal. The equipment passed inspection before and after the event, which leaves a deeper question. Are we missing something buried beneath us? The Earth's magnetic field is generated deep inside the planet, in the molten iron of the outer core, but the crust and mantle can influence how that field behaves on the surface. Different types of rock, metal deposits, and geological structures can warp the magnetic field locally, creating small zones of distortion. Some researchers have wondered whether something beneath the seafloor of the Bermuda Triangle, perhaps a dense iron deposit or an unusual concentration of magnetite, a naturally magnetic mineral, could be warping the field just enough to disrupt sensitive instruments above. In 2023, a seabed survey using magnetometers recorded a few patches of unexpected magnetic variation near the edges of a submerged ridge off the Bahamas. Nothing dramatic, but enough to suggest that there are magnetic inconsistencies down there we still don't fully understand. What's more, these pockets seem to move, not quickly, but gradually, as if tectonic activity is shifting the source just beneath the crust. Even a small adjustment in depth or alignment could cause a temporary spike at the surface, like a signal brushing too close to the antenna. And that raises a possibility that scientists are just beginning to explore. Maybe the Bermuda Triangle's magnetic disturbances are not random, but pulsing. Maybe they appear when deep Earth forces, magnetism, geology, temperature align in just the right way. And maybe those alignments, like the rogue waves and downbursts above, can't yet be predicted, which leaves pilots and sailors navigating a space that looks ordinary but feels wrong. Because when the one thing you're trained to trust, your compass, spins in your hand, it doesn't matter what the weather looks like, you're already lost. Not all dangers in the ocean come from above. Some rise up slowly, silently from deep within the earth itself. We've talked about shifting skies and swirling currents. We've followed planes pulled from their path and ships stolen by invisible waves. But now we look even deeper, down past the ridges and trenches, into the cold, compressed spaces beneath the sea floor. It's here, under the ocean's floor, that something strange and unstable has been building for thousands of years. It isn't rock or magma, it's something far more delicate and potentially far more dangerous. It's called methane hydrate, a crystalline, ice like substance made when methane gas becomes trapped inside a cage of frozen water. These hydrates form under specific conditions: high pressure, low temperature, and the right chemical ingredients. The ocean floor, especially in regions like the Bermuda Triangle, provides all three. These icy compounds can sit buried for millennia, locked away in deep seabed sediments. But when disturbed by a shift in pressure, a rise in temperature, or a tremor in the crust, they can suddenly release the methane inside. And when that happens, the ocean behaves in ways we're still struggling to understand. Because methane is a gas, when it erupts into the water, it doesn't just rise. It changes the properties of the sea around it. Specifically, it lowers the density of the water, turning a solid-looking surface into something closer to foam. And here's the frightening part. If a ship is above that eruption point, it can lose buoyancy almost instantly. One moment it floats, the next it sinks straight down, swallowed without warning, and with no time to signal distress. The theory has existed for decades, but until recently, it was mostly confined to simulations and lab tests. Curious possibilities discussed at oceanography conferences and in footnotes of geological papers. Then came a new wave of data. In 2023, a team of geologists, using deep ocean pressure sensors, detected a series of subtle seafloor shifts near the Blake Plateau, an underwater feature that lies just northeast of the Bahamas. This area sits right on the edge of the Bermuda Triangle. At first, the changes were minor: slight uplifts in the seafloor, minor tremors, and shifts in temperature just below the sediment layers. But when researchers reviewed the data more closely, they noticed something else: tiny pulses of methane gas, rising not from a single rupture, but from multiple points across a broad area. These weren't massive eruptions, they didn't pose any immediate danger, but they were unusual, and they suggested something deeper might be stirring. The pattern matched early signs observed in other methane hydrate fields, like those off the coast of Norway and Siberia, where slow destabilization eventually led to sudden violent releases. It's worth noting that no confirmed methane explosion has occurred in the Bermuda Triangle in modern history, but the region does have the conditions for it, and now it seems those conditions may be shifting. Some researchers believe the changes in ocean temperature due to climate change and shifting current flows are playing a role. Even a small increase in seafloor temperature can start to destabilize hydrate layers that have remained frozen for thousands of years. As pressure builds, the trapped gas has nowhere to go but up, and if several pockets release in rapid succession, the results could be dramatic. Imagine a cargo ship passing over such a spot. The sea looks calm, the weather is perfect, but suddenly the water beneath it becomes less dense, full of gas bubbles and churn. The ship begins to sink, not because of a hole or a wave, but because the ocean no longer supports its weight. In such a case, there would be no warning, no wreckage, no survivors, just another disappearance in a region already known for them. And what makes it more unsettling is that this process leaves very little evidence. Methane gas dissipates quickly in water, and the bubbles themselves don't rise in neat columns. They spread, mix, and vanish. To someone searching from the air, it would look like nothing happened, just empty water where a ship used to be. Researchers are now working to monitor these changes more closely. New instruments, lowered from research vessels, are designed to measure gas seepage, pressure shifts, and thermal changes in real time. But the ocean is vast, and most of it remains unmapped, unwatched, and unfelt. Which brings us to the lingering question: if these eruptions can happen, and we now know they can, how many of the triangle's most famous vanishings might have begun with a single bubble rising from the dark? The ocean forgets slowly, but it never forgets completely. Even as methane bubbles rise from below and magnetic fields twist above, some of the triangle's most enduring secrets lie where they came to rest, not vanished, but waiting. And it is here, among silt and shadow, that another side of the mystery begins to unfold. It's not about what disappeared, it's about what was found. In recent years, with the help of advanced deep sea drones and high resolution sonar, researchers have begun to map the seafloor of the Bermuda Triangle in finer detail, not just to track currents or scan for gas emissions, but to look for the wrecks, the silent witnesses left behind by centuries of travel across these restless waters. And what they've found is something both fascinating and unnerving: a graveyard of ships, some expected, others entirely out of place. In areas long thought to be empty, the drones have uncovered the remains of wooden sailing vessels, some dating back to the 1600s, resting hundreds of meters below the surface. Nearby, the broken ribs of iron-hulled steamships lie scattered across the seabed like skeletal shadows. There are cargo ships, fishing vessels, and even small patrol boats, each one with its own untold story, each one frozen in a moment no one alive remembers. Some of these wrecks are well documented. They match old logs, radio transmissions, weather reports. We know where they came from, what went wrong, and when they sank. But others are more difficult to explain. Several wrecks discovered in recent expeditions have no official record, no known name, no matching disappearance, no log distress call, missing report, or final coordinates. They simply are. One vessel, discovered off the edge of the Blake Plateau, was coated in decades of marine growth. Its wooden planks were intact enough to show signs of craftsmanship from a long past era, but its design didn't match known shipbuilding styles from any particular nation or fleet. There were no identifying markings, no nameplate, just the hollow remains of something that once moved across the surface and then stopped. Why was it there? This question repeats itself as more wrecks are found, each one an anomaly. Some appear too far off course. Others rest in places where no historical trade or migration routes were known to pass. A few are eerily preserved, as if time and biology agreed to leave them alone. One theory is that many of these ships were caught in sudden storms and driven far from their path. But that doesn't explain all of them, especially those found upside down, intact and unopened, in areas with no known meteorological events at the time. Some researchers now suspect that part of the mystery lies not in how they sank, but in why we never knew they were there to begin with. Before satellites and radio towers dotted the planet, many journeys across the Atlantic went undocumented. Sailors disappeared with no one to report them missing. Merchant ships traveled under flags that were later lost to history. It's possible that many of the unknown wrecks belong to forgotten expeditions, erased not by the ocean, but by time. But there's another theory, that some of these vessels were never supposed to be there, that they were off course, not by miles but by entire regions, drawn into the triangle by strange currents, pulled by magnetic drift, or routed incorrectly due to faulty navigation instruments in an age before GPS. In 2024, a collaborative survey between marine archaeologists and data historians revealed that up to 30% of triangle wrecks previously thought to belong to named ships were actually misclassified. The records didn't line up, the dimensions were off. Some ships had been assumed lost in the triangle when they'd actually sunk hundreds of miles away, and vice versa. It's a mess of misplaced stories. A tangle of data, salt, and assumption, which is why underwater archaeology in the Bermuda Triangle is less like solving a puzzle and more like unearthing an unsorted library of loss. Each wreck opens a new page. Sometimes the words are still legible, a cargo manifest, a plate, a bell. Other times there's nothing but shape and silence, and yet it is in this silence that patterns begin to emerge, not just of when and where ships were lost, but how memory itself fails us when the sea decides to keep its version of the story. Long after a plane disappears from radar, after the signals fade and the search crews return home, the wreckage still exists. Somewhere, hidden beneath cold water and drifting silt, the pieces remain, quiet, waiting, undisturbed. And slowly, very slowly, we're starting to find them. As deep sea exploration tools improve, and as researchers push further into the quiet folds of the ocean floor, we're learning that many of the aircraft once thought to be lost forever were never gone. They were simply not where we expected them to be. Over the past few years, new sonar sweeps and remotely operated vehicles, or ROVs, have begun revealing scattered fragments of aircraft deep within underwater canyons and valleys. These are places no one thought to look before, too deep, too far from projected crash zones, too complex to scan. But now, with sharper resolution and longer range drones, we're seeing more than just the surface. We're seeing what lies beneath it. Some of these discoveries came by accident. A mapping expedition focused on undersea geology stumbles across the skeleton of a fuselage. A dive team scanning for wreckage from a 1970s fishing vessel picks up the shape of a wing embedded in a slope of sediment. Other finds are more targeted, the result of newly reanalyzed crash data combined with current and terrain models. In both cases, the result is the same. Planes we assumed had vanished, found far from where they were supposed to be. The reason for this distance lies in the nature of the sea itself. When an aircraft hits the ocean, it rarely stays in one place. Even in calm conditions, the impact breaks it apart. Some pieces float, others sink. But beneath the surface, currents and seafloor features begin to pull at the wreckage like invisible hands. In the Bermuda Triangle, this effect is amplified. The Gulf Stream, as we've seen, is strong and unpredictable. It moves water and whatever's in it over vast distances, both at the surface and in deep layers. A single wing might drift north, while the cockpit sinks southwest. And once on the seafloor, the story doesn't stop. Here, underwater landslides, known as turbidity currents, can cause entire fields of debris to shift. The sediment becomes unstable, begins to move, and drags everything in its path down into deeper canyons or across gentle slopes. Some of these landslides are triggered by storms, others by subtle tectonic shifts no one notices. It's this movement, slow, quiet, and constant, that makes locating lost aircraft so difficult. One example came in 2022 when a sonar team off the coast of the Bahamas detected an unusual shape in a canyon nearly 800 meters below the surface. Upon closer inspection, they found what appeared to be the tail section of a twin-engine plane, half buried but still recognizable. The serial numbers had long corroded, the logbooks had dissolved, but the structure matched that of a small aircraft reported missing in the early 1980s, an aircraft last seen hundreds of kilometers away. That same year, another drone picked up a cluster of wreckage fragments lodged in a narrow crevice, twisted metal, shattered cockpit glass, landing gear still partially attached. These weren't the remains of a single crash, but of multiple incidents, different planes, different decades, all drawn into the same underwater grave. What makes these discoveries especially haunting is how intact some of the parts are. Without air, light, or movement, many pieces rest untouched by time. There is no sign of fire or explosion, only the soft weight of mud, slowly folding over them, and even now, many of these wrecks remain unidentified. No flight plan, no matching disappearance, just aircraft parts lying quietly in a place no one was supposed to be. To make sense of these finds, researchers are combining new tools: seafloor scanners with high frequency sonar, magnetometers that can detect buried metal, and AI mapping systems that model how a falling object might slide, tumble, and drift after impact. Each discovery helps rewrite what we know about missing flights, not just in the triangle, but across the world. And each one brings with it a reminder: the ocean hides things not with malice, but with movement. The silence of the sea is not just depth, it's activity, slow, steady, and far more complicated than we thought. And as we continue to scan deeper, inch by inch, we're learning that the mystery of a vanished plane is rarely about disappearance. It's about displacement, about where it landed, and where the ocean chose to carry it after. Long after the metal settles, after the wings and hulls have been dragged into deep ravines, after the final signal goes quiet, one haunting question still drifts beneath the waves: where are the bodies? Time and time again, ships and planes vanish in the Bermuda Triangle, and while pieces of wreckage sometimes reappear, scattered or sunken, the people on board, the crew, the passengers, often leave no trace. Not a life vest, not a shoe, not even a bone. For families, for investigators, for those who search, this is perhaps the most painful part of the mystery. Not just the disappearance, but the absence that follows. An ocean that gives back parts of the ship, but not the souls who were aboard. For a long time, this absence fed speculation. It seemed impossible that bodies could vanish so completely, so consistently, in such a large number of cases. Stories began to form of alien abductions, underwater prisons, time slips, or something darker pulling people away forever. But the real answer may lie not in science fiction, but in biology. In 2023, a new series of studies by marine biologists working with open ocean preservation labs provided a clearer picture of what happens when a human body enters the sea, especially in regions like the Western Atlantic. The findings were sobering. In warm, nutrient rich waters like those found throughout the Bermuda Triangle, decomposition begins almost immediately. Without the cooling influence of polar temperatures, soft tissue breaks down fast. Within hours, the body begins to lose structure. Within days, it becomes unrecognizable. But temperature isn't the only factor. The ocean is alive, not just with currents and tides, but with scavengers: crabs, small fish, shrimp, amphipods, creatures designed by evolution to clean the sea. And they do their job well. When a body enters their world, it becomes part of the food chain. There is no ceremony, no delay. In one controlled study conducted off the southeastern U.S. coast, researchers submerged a pig carcass, often used as a stand in for human decomposition, at a depth of just 300 meters. Within 3 days, it was almost entirely consumed, By day 5, only bones remained, and even those had started to scatter. At deeper depths, the process changes, but it doesn't stop. In the darker parts of the ocean, where pressure increases and oxygen decreases, different organisms take over. Sea lice, hagfish, eelpouts, they feed not just on flesh, but on the marrow within bones. Even cartilage can be consumed. If the body drifts into a trench, slides into a crevice, or gets buried by shifting sediment, the process can accelerate. And without predators to disturb the site, the ocean takes its time, piece by piece, until nothing is left. Some bodies do float for a while, especially in colder regions or shallower waters, but in the triangle, conditions are rarely so kind. The warm temperatures, combined with strong currents and high biological activity, create a system where very little remains for very long. Even life vests, clothing, or belongings can degrade faster than expected. UV light weakens fabrics. Salt water corrodes. Floating objects are carried far, battered by waves, then eventually sunk. This means that even when a search begins quickly, the chances of recovering a body, whole or otherwise, drop dramatically with every passing hour. And when the wreck isn't found until weeks or months later, if at all, the biological evidence is long gone. What's left is only data, last known positions, fading signals, bits of debris scattered by tide and wind, but no human trace. For marine biologists, this process is grim but natural. For families, it's devastating. For mystery seekers, it feeds the myth that people are being taken, stolen, vanished by something beyond understanding. But nature doesn't need to be supernatural to be absolute. The ocean is not a grave in the way we imagine. It does not hold still. It does not preserve. It does not mark the spot. It receives and then forgets. And so, in the Bermuda Triangle, the vanishing of people may not be a puzzle. It may be the expected result of a world not made to keep us. Which brings us to the next haunting question. When a ship sinks and the bodies fade, what else might lie waiting nearby, preserved not in bone, but in metal, glass, and mystery? Not everything that sinks in the Bermuda Triangle is dragged down by currents or buried by landslides. Sometimes the ocean doesn't need to move at all. Sometimes it simply waits and lets the ships come to it. Because just beneath the surface of the water, hiding where sunlight still dances, lie sharp, jagged coral reefs. And in certain places near Bermuda, those reefs sit just inches below the surface. They are beautiful, intricate, alive, but they are also dangerous. To the casual observer, especially from above, the ocean in this region looks calm, smooth, clear, inviting. On sunny days, it glows turquoise and soft blue. But during storms or under moonless skies, or when waves are high and frothing, that clarity disappears. And when it does, so do the warnings. In these moments, coral reefs become invisible, silent traps floating just beneath a thin layer of salt and wind. They don't shift, they don't move, but they tear. Coral is not soft. It's made of calcium carbonate, the same material found in limestone and seashells. Over time, the reef structures grow taller, wider, and sharper, forming natural ridges, jagged outcrops, and needle-like edges. When a ship's hull makes contact with these formations at speed, the damage is instant. The underside is ripped open, like paper against a blade. Water rushes in, panic follows, and in many cases the vessel sinks before help can arrive, especially if radios are already down or the crew is unaware of exactly what they struck. In recent years, marine archaeologists using side-scan sonar have identified dozens of shipwrecks lodged against coral reefs in the Bermuda region. Many of them rest in shallow water, tangled in sea fans and buried partially in sand. Some are large enough that when first spotted, they were thought to be recently lost ships, mysterious cases tied to triangle disappearances. But when divers got closer, they discovered the truth. These weren't mysterious vanishings. They were collisions, violent, sudden, and entirely caused by nature. One notable wreck discovered in 2021 belonged to a freighter listed as missing without trace since the 1960s. It had been assumed lost in deep water, far from the shipping lanes, but it was found just off the edge of a reef shelf, tilted, broken, its hull sliced wide open by the reef's jagged teeth. It had likely drifted slightly off course in bad weather, and the crew never saw the danger coming. Other wrecks tell similar stories. Small fishing boats found splintered in shallow lagoons, yachts trapped against coral outcrops, their sails torn to ribbons. Even pieces of larger vessels, including lifeboats and debris fields, discovered resting quietly along the reef's edge. These finds have prompted a new wave of investigation. Researchers are now going back through old disappearance records, pairing missing ships with newly discovered wrecks that seem to match in size, build, and age. And while many mysteries still remain, a growing number of unexplained cases are being quietly reclassified, not as vanishings, but as reef collisions. This doesn't solve everything. Not all disappearances can be blamed on coral, but it does highlight something important, that in the Bermuda Triangle, not every threat is strange. Some are natural, ordinary even, but no less lethal. What makes coral reefs especially dangerous is how deceptive they are. They thrive in warm, shallow waters, the same waters that look calm from above. They grow near coastlines, around islands, along underwater shelves, and they don't make noise when you get too close. In the past, sailors relied on depth charts, experience, and visual cues to avoid them, but when storms hit, or instruments fail, or GPS flickers for even a moment, a few degrees off course can bring a ship right into the edge of disaster. Modern sonar and satellite imaging have helped chart many of these reefs, but not all. New coral continues to grow. Old formations change shape, and many parts of the seafloor remain unmapped or incomplete. Even advanced ships with all the tools of modern navigation can find themselves in trouble if a reef rises just a little higher than expected. The sea does not warn us with flashing signs. It builds its blades quietly, over decades, then waits. Not with intent, but with indifference, as if reminding us that beauty and danger often live in the same place. And while shipwrecks might eventually be discovered, the people aboard, as we've seen, are not always found. Which leads us to a different kind of mystery, not about where things vanish, but about why we sometimes look in the wrong place, because we assume nature should be kind. For centuries, maps were not just tools, they were stories drawn from memory, shaped by fear, and inked with uncertainty. And on the maps of early ocean explorers, one mystery appears again and again: islands that do not exist. They had names, they had shapes, some even had coastlines carefully outlined, sometimes with notes: forests inland, safe harbor, or no fresh water. But when later ships arrived at those same coordinates, there was nothing. No land, no reef, only open sea. These were known as phantom islands, places that once appeared on charts, in ship logs, even in letters sent home from distant voyages, only to later vanish. One of the most famous examples is Sandy Island, charted in the South Pacific and appearing on maps for nearly a century. Then, in 2012, when researchers sailed directly over its supposed location using modern GPS and satellite tracking, they found only deep ocean, no shallow rise, no landform, nothing. It was quietly removed from most digital maps after that. And yet, this strange phenomenon isn't limited to the Pacific. In the Atlantic, and especially near the Bermuda Triangle, There are several historical reports of islands that were sighted, described, and then forgotten. Their names are less well known, but the stories are remarkably similar. A Spanish explorer in the 1500s wrote of an island south of Bermuda with steep cliffs and strange trees. Later expeditions searched for it, but it was never seen again. A British sea captain in the 1700s reported finding a narrow strip of land near the Turks and Caicos, just high enough for seabirds to land on. When he returned a year later, it was gone. For a long time, these tales were dismissed as exaggeration. Maybe the captains were lost. Maybe they saw a reef and mistook it for land. Maybe they lied. But now, with new tools and a deeper understanding of how light, air, and water interact, scientists are beginning to re examine these phantom islands, not as fantasies, but as illusions born from real phenomena. One explanation is the fata morgana, a complex type of mirage that can cause distant objects, like ships or icebergs, to appear as towering islands, even floating castles. This occurs when layers of warm and cold air bend light in unusual ways, stacking and distorting reflections over the horizon. To the human eye, these illusions can appear solid and detailed, lasting for minutes or even hours. A sailor might spot a dark line just above the horizon and through a spyglass see what looks like land. He might chart its position, describe its features, and move on, never realizing that what he saw was light bouncing from a distant object or from nothing at all. But illusions aren't the only explanation. Some phantom islands may have once been real land, now erased. In the shallow waters of the Caribbean and the edge of the Atlantic shelf, sandbanks and coral structures are constantly shifting. Over decades, or even in a single storm, they can rise high enough to break the surface. Vegetation can take root, birds can nest, they may last a year or a century. Then a hurricane hits, or the tide changes, and they vanish beneath the waves once more. Satellite scans of the seafloor near Bermuda have revealed dozens of these submerged ridges and flats, many of them within a few meters of the surface. It wouldn't take much, a particularly low tide, a strong wind, a brief calm in the sea, for one of these to appear like land, if only for a short while. This has led some geologists to suggest that old legends of islands that appear and disappear, sometimes called vanishing islands or ghost isles, may be based in fact, not mythical places, but temporary ones. Geography that isn't fixed but shifting. In 2023, researchers using time-lapse satellite imaging tracked a sandbar near the Bahamas that grew, split, and disappeared within just 18 months. During its largest phase, it would have been visible from several miles away, easily mistaken for a permanent island. No one lives there. No one named it, but it left a mark, a fleeting piece of geography seen by machines, long after sailors had stopped looking. Which raises a quiet question. How many of the Bermuda Triangle's strange stories of ships that reported land, then vanished trying to reach it, might be linked not to error, but to the simple impermanence of the sea? And how many more stories were never written down, never mapped, never believed, because the island that stood there yesterday is no longer there today? Even in the age of satellites, the ocean still holds secrets. But now, for the first time, we're beginning to see beneath its surface from space. In 2024, a series of high resolution satellite surveys passed over the Bermuda Triangle, not just capturing the restless skin of the sea, but peering through it. Using advanced spectral imaging and multi beam sonar overlays, researchers were able to compile some of the clearest bathymetric maps ever made of the region. At first, the images showed what was expected: gentle slopes, deep trenches, rippling seabeds. But then, something unusual appeared. In one particular scan, the ocean floor just north of the Bahamas revealed a patch of geometry that did not fit the surrounding landscape. Unlike the natural curves and scattered chaos of the sea, this formation was strangely regular: rectangular outlines, parallel lines, right angles, the kind that nature almost never makes on its own. The shape, about 1.5 kilometers wide, was faint but unmistakably structured. Some researchers described it as looking like the grid of an ancient harbor. Others, more cautiously, compared it to the skeletal remains of a sunken shipyard, or perhaps even a base. Now, no one's claiming Atlantis. Not really, but the formations are there, and they don't map neatly onto known wreckage, volcanic ridges, or coral reefs. There's something else. Scientists have nicknamed the area Grid Alpha, not because they know what it is, but because they don't. It's just a reference point, a coordinate, a question. When sonar imaging from underwater drones was matched to the satellite data, the geometry held. Blocks of seafloor, each hundreds of feet across, appeared raised in formation, like platforms. Between them, deep grooves that seemed too straight, too uniform, too intentional. And yet, there's no sign of human construction. No metal, no artifacts, no wiring, just stone and sediment. Still, the shape persists. Some scientists suggest tectonic uplift or fractured bedding planes, natural causes. Others wonder if the pattern could be the result of ancient undersea landslides that settled in symmetrical ways, but no one can say for sure. What makes it more haunting is its location, right in one of the most active sectors of the triangle, the same zone where sonar buoys have detected unusual pressure anomalies, the same place where compass data sometimes briefly skews, where ships go quiet for seconds or minutes before returning to normal. There's no evidence that Grid Alpha causes any of that, but it's there, silently sitting beneath the currents, waiting to be understood. And it's not alone. Across the triangle, satellites have begun revealing other oddities, not as large, but just as strange. Hexagonal patches of unusually reflective sediment, submerged trenches shaped like concentric ovals, even one site where the seafloor appears to bubble upward as if something pushed from beneath. These features don't appear on older maps. Some may have formed recently, others might have been missed entirely until the right kind of light, bouncing from the right satellite, caught them at just the right angle. It's a quiet reminder that for all our technology, for all our charts and scans and sonar sweeps, we still don't know what's under all that water. And sometimes, the better we see, the more confusing the picture becomes. What's especially strange is how some of these features seem to move slightly, not fast, not in real time, but across data sets from different months. Subtle shifts can be measured, as if the ocean floor itself is breathing or adjusting. In 2025, a research team at the Scripps Institution released a paper suggesting that seafloor mobility in tectonically active zones is more dynamic than previously thought, especially in areas with methane hydrates, hidden fault lines, or slow volcanic swell. Could that explain Grid Alpha? Maybe. Or maybe it's something else entirely, a relic from before we began recording, a remnant of an era when coastlines looked different, when seas were lower, when land that is now drowned once stood tall and dry. Whatever it is, it's real, it's mapped, and it's sparking new interest in an old mystery. Because even from above, with all our satellites, all our lenses, all our algorithms, the Bermuda Triangle continues to hide things in plain sight. And the deeper we look, the more we begin to wonder what else has been there all along, just waiting for the right eyes to notice. There's something especially unsettling about time, not when it drags or speeds up, but when it simply disappears. For decades, pilots and sailors passing through the Bermuda Triangle have told stories that sound more like science fiction than logbook entries. Routine flights that should take 2 hours somehow finish in 45 minutes. Watch hands fall out of sync, Entire chunks of time, sometimes hours, go missing with no memory of where they went. It begins subtly. A plane checks in with air traffic control, reporting position and altitude, everything normal. Then, suddenly, they're off the radar, not lost, not crashed, but simply absent. And then, minutes or even hours later, they reappear somewhere they shouldn't logically be yet, closer to their destination, ahead of schedule, reporting calm conditions but confusion over timing. Pilots insist nothing unusual happened in the cockpit. No turbulence, no storm, just an odd stillness, and then arrival. Commercial captains crossing the ocean by ship report similar episodes. Logs show clear travel speeds, but the math doesn't add up. A journey expected to take 12 hours is finished in 9, and no one on board remembers pushing harder or going faster. Their instruments weren't tampered with. There was no change in engine output, but the ship covered too much distance in too little time. This isn't the kind of thing that can be waved away with simple miscalculation. Many of the reports involve professionals, trained observers, seasoned with thousands of hours in the air or at sea. They rely on precision, on systems that are tested, calibrated, and tracked. So what's going on? Some scientists believe that wind shear at high altitudes may play a role. The atmosphere over the Atlantic, especially near the equator, can be layered in unpredictable ways. Fast-moving jet streams might carry an aircraft further, faster, without noticeable turbulence. A plane flying with a strong tailwind might unknowingly leap ahead in both space and time, arriving early but with no perceived speed change inside the cabin. But that doesn't explain everything. Other researchers have looked at magnetic anomalies, the kind that make compasses spin or shift. While we usually think of magnetic fields in terms of navigation, they also interact subtly with electronics and potentially even the human brain. The Earth's magnetic field isn't a static shield. It pulses, bends, and sometimes surges, especially near tectonic boundaries or places where molten rock moves under the crust. Some theorists propose that strong magnetic fluctuations might create what's known as time dilation, not in the dramatic science fiction sense, but in tiny, measurable ways. Atomic clocks flown at different altitudes or speeds already show microsecond differences. Could localized field distortions be stretching time just enough to make us notice? Possibly, but not proven. Then there's the question of the mind itself. Neurologists have suggested that long hours of repetitive motion, flying over open ocean, or staring at endless blue water, can distort perception. The human brain uses internal cues like the sun's angle, wave movement, and even the feel of gravity to track time. When those cues are disrupted by cloud cover, unusual light patterns, or motionless seas, our inner clocks can slip. Some speculate that the triangle may have unique environmental factors that interfere with this process. The atmosphere above it often shifts rapidly. Light bounces off the water in strange ways. Storm cells can appear and vanish with no warning. These visual and sensory inconsistencies may confuse not only instruments, but also perception. Under certain conditions, a person might experience what's known as transient global amnesia, a sudden temporary loss of time-related memory. It's rare but well documented, and it can occur without any lasting damage. One moment you're mid-flight, the next you're somewhere else, with no memory of how you got there. This strange blend of physics, weather, magnetism, and cognition has led some to wonder, is the Bermuda Triangle less of a physical place and more of a zone of perception? A space where our tools and our minds don't function the way they're supposed to? More questions than answers, as always. But while theories swirl and skeptics scoff, the reports keep coming. Pilots land earlier than expected. Ships cross vast distances in implausibly short times. No two stories are exactly alike, and yet they rhyme again and again. And sometimes what's missing isn't just time, but sound. In the next layer of mystery, we listen not to the clocks, but to the whispers rising from the deep. Sounds no human ear was meant to hear, recorded by machines drifting through darkness, picking up voices the sea never intended to share. Not all storms are loud. Some whisper, some slip in without warning, silent, soft edged, and strange. In December 1970, a pilot named Bruce Gernon climbed into the cockpit of his Beechcraft Bonanza A-36, preparing for a routine flight from Andros Island in the Bahamas to Palm Beach, Florida. The skies were mostly clear. The route was familiar. It should have been uneventful. But what happened next would ignite one of the most enduring mysteries ever linked to the Bermuda Triangle. Shortly after takeoff, Gernon noticed an odd-shaped cloud forming ahead, tall, narrow, cylindrical. Not a thunderstorm, not turbulence, just different. As he approached, the cloud expanded, stretching wide but forming a kind of tunnel, hollow inside, like a vortex. With no other weather on radar and no sign of danger, Gernon flew into it. That's when time began to blur. He later described the sensation as flying through a spiraling tunnel of vapor. The walls seemed to pulse. Electrical instruments began to act strangely. Compasses wobbled. Altitude readings flickered. The radio filled with static. Then the cloud began to close in behind him, not dissipating, but sealing. And in the middle of this eerie tunnel, Gernon saw something he couldn't explain. Flashes of light, not lightning, but something softer and more rhythmic. He felt weightless for a moment. The airplane wasn't shaking, it was gliding, almost floating, as if gravity had temporarily paused. When he finally emerged, the world outside looked wrong. He checked his instruments. Something was off. He radioed Miami Air Traffic Control. They couldn't locate him. Not on radar, not by coordinates, not even by time. And then, just as quickly, he appeared again. But here's the thing. He was nearly 100 miles closer to the coast than he should have been. According to his flight log and remaining fuel, he'd crossed that distance in just a few minutes, which, by all laws of physics and propulsion, was impossible. Gernon didn't believe he'd gone faster. He believed time itself had shifted. The story, of course, drew skeptics. Some chalked it up to faulty instruments, atmospheric distortion, or human error. But others, especially pilots who'd flown similar routes, quietly admitted they'd experienced something close, a sudden fog, a loss of bearings, a silence that pressed in too tightly. Then somehow they'd arrived far ahead of schedule. Scientists remain cautious, but in the years since Gernon's flight, physicists and atmospheric researchers have proposed several possibilities, none of them conclusive, but all of them compelling. One theory involves electromagnetic lensing, a rare effect where energy fields can bend radio waves and light. While usually discussed in astrophysics, especially around black holes, some believe that similar, though weaker effects could occur in our atmosphere under extreme conditions. A sudden shift in magnetic alignment, combined with water vapor and ionized particles, might create a localized bubble of distorted space-time. In such a zone, radar might fail to reflect correctly. Timekeeping systems, especially analog ones, could drift. Even GPS signals, if partially scattered, might briefly lose fidelity. It wouldn't be teleportation, but to those inside, it could feel like skipping seconds or miles. Others have speculated that Gernon's tunnel was a manifestation of a mesoscale convective vortex, a rare but powerful rotating storm that forms in clear air. These systems can twist cloud structures into spirals and generate electrical interference. Pilots passing through them have reported eerily similar sensations, a loss of orientation, instrument glitches, and a slowed perception of time. But none of these ideas fully explain the speed of his transit. To date, no official investigation has disproved his account, but none have verified it either. The FAA recorded the flight as completed with anomalies, but without enough data to assess what happened. What makes Bruce Gernon's case linger isn't just the details, it's the consistency of feeling, the sense described by many who've flown through the Bermuda Triangle of being touched by something unseen, something quiet, disorienting, and elusive. Even now, some pilots report narrow fog bands that don't appear on satellite. A few carry journals where they've scribbled their own unexplained incidents. One described flying into cotton and emerging minutes later over a completely different island. Another said he felt like the plane was flying itself for a few seconds, a strange calm, then a re entry into reality. Perhaps it's all coincidence. Perhaps the atmosphere plays tricks. Or perhaps, under the right conditions, nature opens a kind of corridor, not to another world, but to a place where time stretches, or folds, just enough to leave a mark. From here, our path leads even deeper, not into fog, but into silence, where machines hum, but the sea refuses to echo, where something vast listens in the dark and does not always answer. As radar flickers and clouds distort perception above the surface, there's another world of signals that passes unnoticed, not in the air, but deep below the waves. A world that doesn't light up screens or confuse compass needles, but hums, whistles, moans, and clicks with sounds our ears were never meant to hear. At the bottom of the Bermuda Triangle lies a listening landscape, a place of vibrations and echoes. The ocean, after all, is never silent, even when it looks calm, especially when it looks calm. Beneath that still blue surface is an entire planet of sound. In recent years, oceanographers have deployed hydrophones, underwater microphones, to monitor the acoustic environment of the Atlantic. These sensors are designed to pick up seismic activity, passing ships, and marine life, giving researchers a richer understanding of what happens in the deep when no one's watching. Most of the sounds they record are familiar: rhythmic pulses of snapping shrimp, long mournful songs of humpback whales, and the whispering shift of sandbanks as ocean currents pull them into new shapes. One of the most haunting discoveries came not from a living creature, but from the seabed itself, grains of sand sliding across the seafloor in such a way that they sing. The friction creates a low-frequency hum like the soft ringing of a distant gong, echoing in the darkness below. But alongside these expected voices, something else has emerged. In recordings taken near the edges of the triangle, close to the Puerto Rico Trench, and again off the coast of the Bahamas, hydrophones have captured bursts of repeating frequencies. These aren't like whale songs, which follow natural intervals and pitch changes. They're not sonar pings from passing submarines or echolocation clicks from dolphins. These tones repeat too cleanly and too strangely. Some mimic a pattern, then vanish. Others echo irregularly, rising and falling in pitch, but never long enough to analyze. They don't correspond to any known marine species. They don't appear to come from ships, and they seem to move, not along any shipping route or predictable current, but almost in circles, as if looping through the water before fading into nothing. One recording, captured in 2022 near the Blake Plateau, sent researchers scrambling. It began with a long, high-pitched tone, sustained for nearly 30 seconds, then silence. Then again, exactly 2 minutes later, for hours. No variation, no change, just that note, like a lighthouse beam for the ears. Sonar analysis revealed no metallic object in the area, no vessel nearby, no geological event that would explain a repeating sound of that duration or purity. Some speculated that it could be an unknown kind of marine life, perhaps a deep-sea squid or cuttlefish using a form of low-frequency communication. Others considered the idea of trapped gas pockets beneath the seafloor releasing pressure in pulses, or even cavitation from volcanic activity in the deeper trenches. But none of these theories explained why the signal moved or why it had no echo. Sound underwater usually bounces off rocks, ridges, wreckage, but this tone felt absorbed, as if it was coming from something that didn't reflect anything back. There are also short bursts, digital sounding chirps, that some researchers described as similar to the coded pings used in underwater positioning systems. But when they reached out to commercial and military navies, no source claimed them. In 2024, a collaborative project between marine institutes in Canada, the US, and Spain launched a full month of hydrophone monitoring across a grid pattern that included several known wreck zones. The goal was to triangulate any unusual sounds in real time and try to determine whether they moved with the tides or against them. What they found was subtle but unsettling. Some signals seemed to originate from beneath the seabed, not above it. Low-frequency pulses, spaced evenly, too faint to register without deep filtering. They didn't behave like earthquakes, and they didn't trigger any seismic readings. What's more curious, they were accompanied by pressure changes, slight, almost imperceptible dips in water density, too small to affect a ship, but enough to trigger automated buoy alarms. It was as if something beneath the ocean was shifting, breathing, then falling still again. No official explanation has been released. Scientists remain cautious, calling the findings interesting anomalies, and noting that the ocean is still one of the least understood environments on Earth. But the recordings exist, clean, undeniable, waiting. And so while the surface of the sea remains glittering and serene, the truth may lie not in what we see, but in what we hear, in those faint, eerie tones drifting up from the deep, whispering secrets we don't yet understand. Which brings us to another layer of mystery, not beneath the waves, but across their surface, where ships themselves seem to move on ghost paths, sometimes disappearing from radar entirely. Some disappearances aren't instant, they drift. Sometimes a ship will send a routine message, plot a safe course, and then simply vanish, only to be discovered later, far off track. Not by a few miles, but hundreds. Planes, too, long presumed lost, have been found deep under the sea, in areas they never should have been flying over. It's as if something nudged them or pulled them, quietly, invisibly, over great distances. For years, the explanations have felt obvious: equipment failure, navigation errors, storms pushing vessels off course. But recent advances in ocean modeling and satellite tracking are painting a more complicated and far more fascinating picture. In 2024, a series of high-resolution simulations was conducted by a multinational team of oceanographers using satellite data and underwater sensor arrays placed throughout the Atlantic. What they discovered shook some of their earlier assumptions. Deep beneath the surface, beyond the reach of light and ordinary sonar, lies a churning landscape of spiral flows, slow, powerful vortexes that twist like massive corkscrews through the water. These aren't surface level eddies that swirl gently in the wake of ships. These are deep ocean spiral currents, sometimes stretching for hundreds of miles, spinning thousands of feet below. What surprised scientists most wasn't just their presence, but their force. Some of these spirals travel at velocities strong enough to displace wreckage, drag debris into underwater canyons, or even subtly shift the course of a submerged vessel. A plane that crashes into one area might not stay there for long. Weeks or months later, it could be lying under a different patch of ocean entirely. And then there's the magnetic side of the story. Earth's magnetic field isn't as smooth as we once believed. It's not a gentle, uniform dome, but a restless pattern of peaks and troughs, especially near fault lines or submerged mineral deposits. In the Bermuda Triangle, Multiple regions show signs of localized magnetic anomalies, spots where magnetic north wavers, compass readings skew, and flight instruments experience momentary confusion. These anomalies, when paired with electrical storms or shifting ionospheric pressure, can create magnetic eddies, pockets of swirling energy that may not just affect navigation, but even subtle structural movements in metallic objects like aircraft or shipwrecks. Now imagine a cargo ship, already weakened by time, lying at the bottom of the sea near such an anomaly. Over weeks or months, the constant tug of an unseen current, combined with a gentle magnetic push, could shift it along the seafloor. Not rapidly, not dramatically, but slowly, steadily, until it rests somewhere no one expected to find it. This may help explain why multiple wrecks, once believed completely missing, were eventually discovered well outside projected crash zones. In some cases, researchers dismissed initial search areas because they had already checked there. But new modeling suggests the targets may have moved, carried away by currents that behave less like rivers and more like rotating gears embedded deep in the Earth's aquatic machinery. There are even whispers among some geophysicists of something more exotic. In rare areas of the Atlantic Ocean, the local gravity field, the strength with which Earth pulls objects toward its center, varies slightly due to the density of rock formations beneath the seabed. These are known as gravitational anomalies. They're tiny in measurement, a person wouldn't feel them, but over time, especially on drifting debris or lightweight fuselages, even a small gravitational variance could affect motion, especially when compounded with current flow. It's still a developing field of study, but the possibility raises an eerie thought that some wrecks may not just drift, but be gently attracted, drawn toward denser pockets of the Earth, as if answering a silent call. This idea, while still controversial, is being taken seriously enough that search and rescue algorithms are starting to include gravitational variance maps when projecting potential drift paths, and it's changing how investigations are conducted. Teams are no longer searching only where last contact occurred. They're tracing fluid trails across multiple layers, not just surface wind and water, but deep spiral vectors, electromagnetic curves, and subtle gravitational slopes. Each wreck tells a story not just of how it fell, but how the ocean, in all its invisible complexity, carried it away. Not maliciously, not mysteriously, but with patterns we're only beginning to understand. Beneath the Bermuda Triangle, space doesn't behave the way we assume it does. It bends, it spins, it nudges things quietly into shadowed corners. And even when we finally find them, they rarely lie where logic says they should be. From here, we descend further still, not through movement, but silence, a silence that scientists have measured and cannot fully explain. Not every mystery in the Bermuda Triangle is about something disappearing. Some are about things appearing where they shouldn't. As deep-sea drones glide across the sea floor, sweeping their soft sonar beams across ancient ridges and silt-covered valleys, more and more wrecks are being discovered, battered skeletons of ships no one knew had ever sunk. But what happens when one of those wrecks doesn't match any known record? When a ship lies in perfect silence, without a name, without a log, and without a time? This has happened more than once now, and what makes it even stranger is what the scientists are finding when they date the wood, the metal, and the barnacles clinging to these forgotten hulls. Using radiocarbon dating, isotope analysis, and new ocean depositional aging models, researchers are beginning to realize that some wrecks might be far older than anyone expected. In one case, a sunken vessel was found about 80 nautical miles northeast of the Bahamas. At first glance, it appeared to be a European colonial era ship, maybe Spanish, judging by the construction techniques: wooden ribs lashed with iron nails, and a keel shaped for speed across trade routes. But when researchers from a university marine archaeology team examined fragments of the timber more closely, the carbon isotopes suggested the ship could have been built and wrecked nearly a full century before the earliest known records of ships traveling that specific path. This presented a quiet but jarring problem. No known expedition was recorded in that region during that era. No merchant logbook, no colonial manifest, no pirate ledger, and yet the ship was there, rusted, waterlogged, and unquestionably real. How does a wreck like that end up in the wrong century? One theory suggests simple misidentification. Perhaps the ship drifted far from a better documented route, or perhaps it was never officially registered. In the age of empires and exploration, after all, not every voyage was written down, especially if it was secret, illegal, or doomed before it ever reached port. Smugglers, defectors, rogue traders, their ships wouldn't have left much behind, except for the occasional cannon or a tangle of collapsed planks on the seafloor. But what if some of these wrecks didn't just fall through the cracks of history? What if they belong to routes we've forgotten entirely? That's a possibility some marine historians are beginning to explore. Hidden sea lanes, passed down through oral traditions or navigated by stars before the invention of modern charts. There is growing evidence that ancient mariners, including indigenous Caribbean peoples, pre-Columbian explorers, and even early West African sailors, may have traveled much farther and more frequently than we once believed. Some of these wrecks might belong to ships that were never meant to be known by the systems we use to track history. One wreck, found partially buried off the coast of Puerto Rico, contained ballast stones not native to the Americas, but also not traceable to typical European supply sources. Geochemical testing suggested they might have come from North Africa, and yet the ship's design was hybridized, part Mediterranean, part Caribbean. It shouldn't exist, and yet it does. Another was found deep in a trench, not broken apart, but settled almost gently in a sandy pocket, as if lowered there by careful hands. There were no signs of explosive damage, no hull breach, no obvious reason for it to be resting in silence at the bottom of the ocean. It was as if time had simply stopped for it. The deeper the submersibles dive, the more these anomalies emerge, shipwrecks that don't belong, materials out of place, nails forged from alloys not commonly used in the periods they seem to represent, timbers that have aged differently, and that raises new questions entirely. Could underwater preservation vary so dramatically from one part of the triangle to another that it skews our sense of time? Are the mineral-rich waters accelerating or slowing decay in strange ways, confusing our dating techniques? Or, and this is where the speculation sharpens, could some of these vessels have been carried, dragged, or even submerged from other eras by unknown geological or current-based processes? There's even a fringe hypothesis that the triangle might be a kind of natural time vault, not because of sci-fi style distortions, but because of how pressure, salinity, temperature, and isolation can preserve wrecks that should have vanished long ago. What's certain is this: marine archaeologists are now working with geologists, metallurgists, and historians to redate and re-examine everything they find, because too many things aren't where or when they're supposed to be. Some wrecks are known and named, others remain anonymous, but the ones that trouble researchers most are the ones that whisper from the wrong century. And as the ocean gives up more of its secrets, we're starting to realize that the Bermuda Triangle doesn't just erase things, sometimes it gives them back, but only after we've forgotten. Just when it seems the mysteries of the Bermuda Triangle couldn't possibly grow darker, deeper, or more elusive, there's a place, a scar in the ocean floor, that challenges even the most advanced tools of modern science. It's called the Puerto Rico Trench. Stretching for hundreds of miles just north of the island, This is the deepest point in the entire Atlantic Ocean. In its most shadowed descent, the seafloor plunges nearly 28,000 feet, almost 5.5 miles straight down. To put that into perspective, if Mount Everest were dropped into the trench, its peak would still be submerged under more than a mile of water. This isn't just a deep spot, it's a geological abyss, and it sits quietly along the very edge of the Bermuda Triangle. For decades, explorers and oceanographers have avoided the trench not out of fear, but because of its technical challenges. It's not easy to send instruments into such crushing pressure. Submarines can't reach it. Sonar becomes scattered. Lights vanish within seconds. It is not just dark, it's absolute black, a void that absorbs both sound and light like a mouth swallowing silence. And yet, this trench may hold answers. Many of the aircraft and shipwrecks tied to Triangle lore have simply never been found. While some are rediscovered in shallow reefs or sediment covered plains, others, perhaps many, may have tumbled silently into this abyss, slipping past the continental slope like leaves vanishing into a bottomless well. This theory gained new attention in 2023 when an international oceanographic team launched a series of autonomous deep sea probes into the Puerto Rico Trench. These probes were equipped with pressure sensors, particle samplers, sonar scanners, and high intensity lights. They weren't looking for lost planes, they were searching for tectonic activity, but what they found was something unexpected. Roughly 19th, one of the probes recorded a brief but powerful spike in surrounding water pressure, not consistent with natural seismic tremors or undersea landslides. The pressure anomaly came without warning, lasted for just under 6 seconds, and then vanished. It was as if something large had rapidly displaced a volume of water nearby, something that didn't reflect on sonar. There was no earthquake, no detectable tremor, and yet the data logs confirmed it. The water around the probe had been temporarily compressed, not shaken, not stirred, but pushed. Some scientists suggest this could have been a gas eruption, a sudden blast of methane or carbon dioxide from under the seabed, releasing enough force to disturb the column of water. Others think it could have been the collapse of a hidden cavern wall or a surge from deep tectonic movement. But what struck the researchers most wasn't the anomaly itself, it was how completely silent it was. No noise, no rumble, just data and then stillness. The probe continued its descent. At 24,000 feet, visibility dropped to almost zero. Organic particles became sparse. Even the usual deep sea creatures, the bioluminescent shrimp, the ghostly jellyfish, the eel like hunters, seemed to disappear. It was as if the trench had entered a different kind of zone, one without life, without motion. Then, at 26,700 feet, the probe stopped responding. No signal, no return, not even a static ping. To this day, it hasn't been recovered. This wasn't the first time a probe had been lost in the trench, and it likely won't be the last. But it added another shadow to the triangle's long silhouette. Because if something, anything, were to fall into this abyss, it would be gone, forever. No black box, no wreckage, no clue. And that's what makes the Puerto Rico Trench more than just a deep spot on a map. It's a perfect eraser. Currents there are complex, spinning like underwater whirlwinds. Pressure is unstable in places. Temperatures fluctuate without explanation. And the sediment layer upon layer of marine snow and crushed calcium can bury an object in days, hiding it in a cocoon of silence that not even sonar can penetrate. Some researchers believe that the trench may be growing, stretching slowly as the Caribbean plate shifts against the North American plate. If this is true, then its capacity to absorb, to consume, may only increase over time, and that raises even more questions. Could some of the triangle's most baffling vanishings, especially the ones with zero debris and no distress call, have simply slid, unseen, into this gaping fissure? And if so, what else might be down there? We've only mapped about 10% of the trench in high resolution. The rest remains a mystery, a dark fingerprint pressed into the edge of the earth. But we're not done diving, because while the trench may erase evidence, the sounds of the triangle offer clues of their own, strange ones, because in some regions of this mysterious triangle, sonar simply stops working. Some of the deepest mysteries tied to the Bermuda Triangle don't lie in the sea, they lie in what remains unread below a redacted stamp. Decades after official inquiries into plane and ship disappearances, certain documents remain partially blacked out or completely withheld. Even the details of incidents like Flight 19 and subsequent Navy search missions still include redactions. Portions of communication logs, radar data, and trajectory reconstructions are labeled classified or withheld in interest of national security. When families request records through the Freedom of Information Act, they sometimes receive pages so heavily censored they are unreadable, columns of ink blotting out lines of text, leaving only headers and titles. Requests for specifics about instrument readings or sensor logs often draw generic responses, records restricted for operational security or withheld due to potential compromise of strategic assets. The silence raises questions. What could be so sensitive that official agencies still guard it long after the events occurred? In some instances, researchers and journalists have uncovered internal Navy references to experimental radar interference testing conducted during the 1960s and 70s in the Atlantic, tests designed to mimic jamming scenarios. These were meant to evaluate how aircraft and ships respond when their GPS, navigation systems, or communications are scrambled. While some test zones were public knowledge, investigators believe parts of those exercises coincided with areas that later became infamous for disappearances. Yet the related incident reports lack clarity or corroboration. That gap has created space for speculation, including the idea that the Navy may have tested equipment capable of producing localized electronic blackouts. If such a system malfunctioned or malfunctioned intentionally, it could explain how some vessels or aircraft suddenly lost communication and radar contact with no distress signal. But without unredacted data, it remains conjecture. Other lines of thought look beneath the surface, literally, to the underwater terrain. The triangle overlaps with multiple undersea cable routes and submarine surveillance networks. These cables carry sensitive data between continents. Some theory suggests that occasionally a ship or plane might have collided with these installations. If so, official reports might be muted to prevent revealing the location or security importance of those cables. Beyond technology or infrastructure, there's the quieter theory that what's suppressed may not be mechanical, but natural, anomalies that don't fit existing frameworks. In some redacted files, researchers have identified references to unexplained instrument fluctuations, sudden turns in magnetic data, or bursts of pressure in seafloor logs that had no immediate cause. These irregularities were treated as anomalies rather than outright phenomena, but the language used, such as anomalous reading or unexplained deviation, indicates uncertainty. The official explanation for withholding information remains consistent: national security. But that label is broad. In practice, it can include classified defense projects, unmapped submarine infrastructure, or intriguingly, geophysical phenomena that defense agencies prefer to study discreetly rather than broadcast loudly. The result is a layered opacity. Families and investigators see incident names and dates, but the critical why remains obscured. And yet, even within this quiet, a pattern emerges. Multiple scuttled reports, one-off errors, or bandwidth limitations might explain individual omissions. But when you accumulate decades of redacted files spanning multiple cases and consistently tied to the same geographic region, the silence becomes significant, not necessarily suspicious, but undeniably incomplete. In a rare instance, an expurgated Navy document referenced a joint oceanographic military dive operation, where standard dive lights and navigation compasses failed at minimal depths. The log simply notes divers reported disorientation and delayed communication. That section was quickly marked classified and never reopened. In the absence of larger context, curiosity grows, especially because the Bermuda Triangle has amassed hundreds of similar reports describing disorientation, instrument failure, and unexplained environmental feedback. Over the years, analysts have searched public and semi-public forums, maritime logs, pilots' journals, retired officers' testimonies, to see if any suppressed details leak outward. Some retired personnel have claimed that operational communication exercises in past decades sometimes went wrong, that an aircraft might lose contact, appear to vanish, then reappear miles off course, all due to electromagnetic interference generated during training. If those exercises coincided with the paths of civilian or scientific flights, the event may have become an unreported incident, quietly recovered and archived in internal data. But again, these remain theories unconfirmed, uncorroborated by official releases. Without the full records, we are left to infer gaps by examining patterns of silent flight records, sudden course deviations without causality, anomalies in sonar coverage that end without explanation. The common thread is that someone had information but refused to share it. That refusal feeds the enduring narrative, not that the triangle consumes things entirely, but that it consumes them quietly. Official documents vanish into classified vaults, sensor data disappears into private archives, colleagues swear oaths, judges seal courts, and what the public sees is only part of the map. The rest, locked behind terms like not releasable, subject to redaction, or exempt from disclosure. All of this matters because in many cases, the sinking or crash itself may generate data that contradicts simple natural explanations. If structural failure is ruled out in official reports, but the files are withheld, then a path opens for speculation that official agencies are aware of forces at play, possibly unknown anomalies, that they are still scrutinizing internally. It does not mean there is a conspiracy to hide magical forces, but it does suggest that even now, decades later, the Navy and other agencies may be grappling with the limits of what they can explain and the consequences of what they cannot. Which brings us back to the sea itself, where the deepest mystery may not be whether something vanished, but whether we ever had consent to know why. The ocean has always stirred something ancient in our minds. It's vast, unknowable, and indifferent. When things vanish into it, our thoughts don't always follow logic, they veer toward legend. But what if that reaction, the one that leaps to the strange and supernatural, isn't just imagination, but something wired into how we think? Cognitive scientists have studied how the human brain reacts when it encounters chaos, especially in high stress, high uncertainty situations, like a ship suddenly disappearing from radar or a plane vanishing mid flight. In these moments, we instinctively search for patterns, for meaning, even when none may exist. This tendency is called apophenia, the mind's natural drive to see connections in randomness. It's what makes us think a rustle in the leaves might be a predator. It's why we see faces in clouds, meaning in coincidence, or mystery in mechanical failure. Apophenia helped our ancestors survive by erring on the side of suspicion, but in today's world, it often leads us to misunderstand what we're seeing, especially when fear is involved. In the case of the Bermuda Triangle, that fear is deeply rooted, a place marked by maps and memory as dangerous, strange, unsolved. When any incident occurs in this region, whether mechanical, navigational, or natural, our brains immediately begin stacking it against every other story we've ever heard about the triangle. A simple compass error becomes the instruments went wild. A delayed rescue becomes the ship vanished without a trace. The more uncertain the facts, the more room our minds have to invent explanations. And the more dramatic the unknowns, the more likely we are to assume something beyond reason. This is known as agency detection bias, a psychological trait where we assume that if something happened, someone or something caused it. So when a plane disappears and we don't understand why, our first instinct is not weather or mechanical error, but what unseen force did this. In truth, many Bermuda Triangle incidents have had logical explanations. Planes running low on fuel, ships steering into unexpected storms, navigation systems failing due to known measurable interference. But when the explanations are incomplete or slow to arrive, the gaps are filled with narrative. And the most lasting narratives are the mysterious ones. Psychologists have also noted that group memory, the collective way societies remember events, tends to amplify drama over time. The original report might describe a plane going down in rough weather, but over years, retellings add uncertainty. The weather becomes perfect, the crash becomes a disappearance, and the distress call becomes a cryptic final message. This slow exaggeration builds, not through lies, but through fear fed storytelling, each retelling shaped by the teller's own imagination, doubts, and cultural memory. Media also plays a role. In the 1950s and 60s, tabloid headlines began using the term Bermuda Triangle for the first time, not in scientific journals, but in speculative articles and adventure magazines. These stories often omitted key details like poor flight planning or ignored weather warnings, and instead highlighted the strange, the sudden, the unexplainable. And once a region is labeled mysterious, every future event within it begins to echo with that same tone. This is known as confirmation bias, when we selectively interpret events to support what we already believe. If someone thinks the Bermuda Triangle is dangerous, every incident becomes proof, and any event that doesn't fit the pattern, it's ignored or forgotten. Over time, this filters the facts, shaping a version of the world that feels more eerie than it is. But there's another factor, the physiological response to fear itself. In high stress environments, our brains release cortisol and adrenaline, hormones that narrow our attention, accelerate our heartbeat, and prioritize instinct over reasoning. In these states, even experienced pilots or sailors can misinterpret what they see. A flash of lightning might feel like an explosion. A momentary blackout becomes a time warp. Instrument dials behaving normally might seem erratic if the operator is panicking. In this way, fear doesn't just distort memory, it reshapes perception in real time. And when people return from the triangle with stories, or fragments of stories, those stories carry the weight of emotion. Even if every technical detail has a rational cause, the sensation of confusion, of time slipping, or of being lost in a storm with no warning feels profoundly real. And so the legend is reinforced, not by fiction, but by human experience filtered through fear, confusion, and the need to make sense of the senseless. Scientists studying these psychological patterns emphasize that myths like the Bermuda Triangle aren't necessarily false, they're reflections of how we cope with uncertainty. In an environment as unpredictable as the open sea, especially in a region known for sudden storms, shifting currents, and incomplete data, we use stories to bring order, even when the real cause is buried deep in the ocean or deep in ourselves. So when we talk about the Bermuda Triangle, we aren't just mapping a piece of the ocean, we're mapping something inside the human mind, a place where mystery multiplies, where emotion builds echoes, and where fear, quiet, patient fear, continues to shape the stories we believe. And those stories, once formed, are remarkably difficult to let go. The ocean has always been a mirror, not just for the sky, but for the quiet spaces in us, that long for something more, something unsolved, something impossible. That's why, even after decades of scientific studies, expert reports, radar data, and rational theories, the Bermuda Triangle still holds its grip on the human imagination. It isn't just about a patch of sea between Miami, Bermuda, and Puerto Rico. It's about the idea that maybe, just maybe, there are still places on this earth where logic doesn't hold all the answers, where things happen without explanation, where reality folds in on itself, and the rules we've built our world on, physics, time, space, cause and effect, blur at the edges. People don't hold on to these stories because they haven't heard the science. They hold on because they want the story. They need the mystery. In a world that feels increasingly mapped, tracked, and explained, the idea that something, anything remains wild and unknowable is comforting, even thrilling. And so the triangle becomes more than geography. It becomes folklore, a living legend. Ask someone about the Bermuda Triangle, and they may not be able to name a single ship or plane that disappeared, but they'll tell you it's dangerous, that compasses don't work there, that pilots vanish, that there's something strange in the water. These aren't facts, they're feelings, shared through stories, carried across generations, reinforced not by data, but by belief. And belief is powerful. Psychologists call this narrative identity, the idea that people shape their understanding of the world through the stories they tell and retell. When those stories become part of a culture, they persist even in the face of contradicting evidence. Because they serve a purpose, they give us symbols, anchors, lessons, warnings, wonder. The triangle offers a unique kind of wonder, one that blends fear with fascination. It reminds us that even the most advanced technology can fail, that even trained professionals can get lost, that nature at its core is still capable of humbling us. But it also speaks to something deeper, our hope that reality is not as rigid as it seems. When people imagine ships vanishing or planes slipping silently off radar, they're not always thinking about tragedy. Sometimes they're thinking about possibility. What if they crossed into another dimension? What if time bent? What if there's more to this world than what we can see? These thoughts aren't scientific, but they're deeply human. Even the language we use reveals our attachment. We don't say a ship was lost in bad weather. We say it vanished. We don't say equipment failed. We say the compass spun wildly. The words stretch toward drama because drama gives shape to mystery. And every time a new incident occurs, even something easily explained, it breathes life back into the story. A missing aircraft becomes headline news, not just because of the people on board, but because of where it happened. A storm sunk freighter is whispered about in forums and late night radio as another triangle event. The myth is self reinforcing. Every curious article, every TV documentary, every friend who says, "Have you heard what happened?" adds another thread to the web. Over time, it becomes impossible to separate the facts from the feeling. But perhaps that's the point. Some stories are not meant to be solved. They're meant to be held, to be passed down, reshaped by each generation, like smooth stones turned over in the hand. The triangle may never be fully explained, not because there isn't enough science, but because there's too much soul tied up in its legend. We like having places that defy easy answers, places that say, here, the rules don't apply, because it means there might be more waiting beyond what we know, that the world isn't done surprising us. That mystery, real, aching, wide eyed mystery, still exists. And so the Bermuda Triangle endures, not because of ships, not because of science, but because deep down, we want there to be a place where reality slips just a little, a place that reminds us we're not finished asking questions. That wonder still floats just beyond the horizon, that some corners of the map, no matter how many times we scan them, still whisper back, "Not yet." Even after all the research, all the sonar scans, the weather simulations, the current mapping satellites and radar logs, some things still refuse to line up. Science has brought clarity to many parts of the Bermuda Triangle's story. We now understand how rogue waves can rise like liquid walls, how methane pockets might bubble up and turn seawater into a deadly trap. We've charted the seafloor and found wrecks thought long lost. But even with all of this, the sea still holds its silences. There are places just coordinates on a map where compasses twitch for no reason. Not gradually, not like a slow shift in magnetic north, but erratically with no pattern. Pilots have reported watching their instruments spin in place, even when sky and sea appear calm. The explanation often offered is magnetic declination, the natural difference between magnetic and true north. But these shifts, some of them sharp and short lived, don't follow the expected rules. They can't be replicated in simulations. They don't always show up in the black box data, and once they're gone, they leave nothing but questions. Ship captains have told similar stories. Modern vessels are equipped with GPS, gyro compasses, radar, tools meant to eliminate confusion. But on rare occasions, everything goes quiet. Not because the systems fail, but because the data no longer matches the reality around them. The ship is there, the horizon is visible, but the numbers don't add up. It's as if for a moment the vessel doesn't know where it is, and neither does the ocean. And then there's the matter of debris. When planes or ships go down, search teams know how to model drift. They know how long it takes for wreckage to rise, scatter, or sink based on weather conditions and current speeds. But in several triangle incidents, debris has shown up hundreds of miles off course, or not at all. Some objects seem to vanish without a trace. Not a single seat cushion, no oil slick, no emergency beacon, nothing. It's not supposed to work that way. Even in deep water, something usually remains. A floating life vest, a wing fragment, a hatch, a raft. But sometimes there's just absence. And when search teams arrive at the last known coordinates, they find calm seas. No sign of struggle, no sign of life. In a few rare cases, wreckage is eventually found, but in places so far from the projected path that experts can't explain how it traveled such a distance. Not with the known currents, not with the time window. It's as if the rules bent, not broken entirely, but softened, just long enough for reality to twist. And then there are the people. There have been disappearances where all communication ceased mid-sentence, not due to electrical failure or battery loss, but mid-transmission. Something's wrong, a voice says. We can't see the horizon. Then static, forever. Recovery teams have found planes with no one on board, life vests stowed, no signs of struggle, no signs of escape, just silence inside an intact craft. In one well-documented case, a distress signal was received from a vessel whose coordinates were off by nearly 200 nautical miles, and when the ship was eventually reached, it was empty, food still on plates, coffee half full in mugs, but the crew was simply gone. Science has theories: decompression sickness, rogue wave strikes, structural failure at speed, but none explain why everything else was undisturbed, why no one radioed again, why a dozen trained professionals would vanish with no effort to survive. And this is where science begins to blink, not because it lacks the tools, but because the questions reach into areas that instruments can't always measure. What happens to human perception when magnetism distorts subtly over time? What if spatial orientation is warped not violently, but quietly, just enough to confuse, just enough to delay, just enough to make a wrong turn irreversible? What if the ocean sometimes becomes a mirror, not just of the atmosphere above, but of uncertainty itself? What if some answers, Not all, not most, but just a few, lie somewhere between physics and psychology, between deep sea geology and deep human fear. Science seeks to explain, but the sea, at times, only deepens the riddle. Even as sonar pulses reach deeper, even as satellite eyes grow sharper, and even as every magnetic ripple is logged and modeled in a database, the mystery of the Bermuda Triangle still clings to something older than science, something that resists being filed away or explained. Because while data narrows the questions, it doesn't erase the feeling that this corner of the ocean knows it's being watched, that it responds not violently, but quietly, that there's a rhythm beneath the waves, older than ships and newer than understanding, and maybe that rhythm doesn't want to be found. For every compass that's corrected, there's still a story passed down from pilot to pilot, sailor to sailor, of a time when the ocean didn't behave, when directions blurred, when the sky shimmered like heat on asphalt, even with no sun above, when time itself stuttered, or vanished, or bent. These aren't always the kinds of stories you'll find in academic journals, but they persist because they were lived, or at least felt, and what we feel, we remember. Science doesn't aim to take that away. It doesn't need to disprove wonder. It simply seeks patterns. It listens closely. It refines. But in places like the Bermuda Triangle, science often finds itself walking alongside something else, something more human. Imagination, pattern seeking, story. In the early days, long before satellite feeds and flight data recorders, sailors navigated by intuition and stars. They trusted the wind, the sound of the hull, the color of the water. When something went wrong, when a ship vanished, or a compass spun, or a shadow moved where no cloud had passed, it wasn't just a technical failure. It was a sign, a whisper from the deep. And so the myth was born, not out of ignorance, but out of reverence, out of the need to name the unnameable, to point at a blank place on the map and say, there, that's where the world frays. Even now, with explanations growing more detailed each year, there's something about the Bermuda Triangle that resists resolution. It's not just about what has happened there, it's about how it's happened, about the eerie consistency of confusion, the silence that falls too suddenly, the radar pings that never bounce back, the final messages that end with no cause, the drift paths that lead to nowhere, the wrecks found far from logic, and the lives, over 1,000 of them, that stepped into the triangle and never stepped out again. And this is where myth finds its footing, not in replacing truth, but in holding space for what truth hasn't fully caught up with. Because sometimes stories are not lies, they're placeholders. They sit quietly beside science and say, when you're ready to understand more, I'll be here. Even scientists, those most committed to logic, evidence, and method, have admitted to feeling uneasy in the triangle. They don't call it supernatural, but they do say things like unusually active, unexpected anomalies, regions of statistical outlier behavior, and perhaps that's just a more careful way of saying we don't fully know, but we feel something, and that feeling matters, because the myth isn't just about vanishing ships and strange lights. It's about possibility, about awe, about the idea that the world is not yet fully unwrapped, that somewhere there are still pockets of surprise, that maybe not everything has been pinned down, not every shadow mapped, not every echo understood, and maybe, just maybe, that's a good thing, because if we knew everything, we'd stop looking. But the Bermuda Triangle keeps us curious. It invites questions. It holds space for wonder. It reminds us that for all our machines and models and maps, we are still deep down explorers, not just of oceans, but of the invisible, not just of coastlines, but of mystery, and not just of facts, but of the stories that rise between them. As the last echoes of older legends begin to fade into digital archives, a new generation of explorers is quietly preparing to descend into the triangle with tools their ancestors never imagined. No longer relying solely on compass needles or grainy sonar, the missions planned for 2026 and beyond carry with them sensors that can map the ocean floor inch by inch, submersibles that can dive for days, and artificial intelligence that can detect subtle anomalies no human eye would catch. This is not just another expedition, it's a convergence, a collaboration between NOAA, the National Oceanic and Atmospheric Administration, and several private ocean tech companies who have quietly pooled their resources, not for treasure, not for fame, but for clarity, for answers. What exactly lies beneath the triangle's deceptively calm waters? What stories have settled under centuries of silt? What forces move silently through the trenches, ridges, and uncharted scars that stretch between Miami, Bermuda, and Puerto Rico? The missions won't just skim the surface, they'll go deep, ultra deep. Some of the equipment, like the newly upgraded Bathystar AUV, an autonomous underwater vehicle designed for long range dives, can remain submerged for up to 3 weeks at a time. It moves without tethers, guided only by satellite signals and pre programmed curiosity. Its sonar can penetrate several meters below the ocean floor, detecting voids, shifts, and wreckage buried in underwater canyons long forgotten. There are also plans to deploy the Triton Abyss, a specially designed two-person submersible capable of descending to depths of over 36,000 feet, the same kind of vessel used to reach the Mariana Trench. This time, though, its destination will be the Puerto Rico Trench, the deepest known part of the Atlantic Ocean, and a place often whispered about in the context of sudden disappearances. Why do objects vanish there without a trace? Could there be deep caverns into which debris silently drifts? Could sudden tectonic shifts, undetectable from the surface, be swallowing wrecks whole? The upcoming missions hope to record pressure differentials in real time, track unexpected acoustic anomalies, and perhaps most significantly, capture visual footage in complete darkness using next gen bioluminescent cameras. But even as the technology grows sharper, many involved in the project hold a quiet belief that some mysteries are not waiting to be solved. They're waiting to be seen and still won't fully give themselves away. Some of the lead researchers, including Dr. Sleta Santos from NOAA's Ocean Mapping Division, have stated that while they anticipate finding previously uncharted underwater landslides, abandoned wrecks, and possibly even ancient seabed faults, they do not expect to solve the cultural and psychological weight of the triangle, because for every aircraft wing located, for every cargo manifest confirmed, there will likely be more questions, new inconsistencies, signals that don't match, routes that shouldn't make sense. Already, earlier test runs in late 2025 revealed strange discrepancies. A sonar sweep near the southern edge of the triangle picked up what looked like a symmetrical ridge, flat on top, steep on both sides. Yet when the area was rescanned 2 weeks later, the feature was gone. The same coordinates showed nothing but gently sloping sand. Was it an error? A shift in sediment? A trick of the sonar? Or something else? This single blip has quietly fueled speculation within the teams. Some now wonder whether the ocean floor itself is more active than previously thought, that the region may not be static, but breathing, shifting, hiding, revealing, then hiding again. Meanwhile, marine biologists assigned to the expeditions have their own questions. What unique ecosystems thrive within these unexplored trenches? Could some of the disappearances be linked to deep sea life forms we've yet to catalog? The 2026 missions will include plankton samplers, microbial colony nets, and even experimental sensors designed to detect faint electromagnetic pulses, not just from machinery, but potentially from unknown biological sources. Because if the Bermuda Triangle hides wrecks, it may also shelter life, life that has adapted to silence, to pressure, to watching from below. One of the most intriguing instruments being prepared is a long range signal buoy that will drift across the triangle's boundaries, designed to pick up infrasound, ultra low frequency sound waves below the range of human hearing. These vibrations can travel hundreds of miles through water and may reveal seismic or subaquatic activity long before it's visible, or some quietly suggest something else. And yet, as the scientists fine tune their tools and review their mission protocols, a strange paradox hovers over every checklist and calibration: the idea that with every question answered, a dozen more may rise. Because the triangle is no longer just a legend, it's a study zone, a living, shifting riddle, one that has been whispering its secrets to the ocean for centuries. And now, finally, we are learning how to listen. For decades, we've drawn tidy borders on the map, a triangle connecting Miami, Bermuda, and Puerto Rico, and we've treated that area as if it were a container, a haunted chamber of sea and sky, locked to that specific geometry. But what if that's the wrong question? What if the Bermuda Triangle isn't so much where, but what? What if it's not a place, but a phenomenon? A shifting effect, a set of conditions that converge, sometimes here, sometimes elsewhere. An invisible pattern with no fixed coordinates. Some scientists have begun quietly exploring this idea. Instead of focusing solely on disappearances inside the classic triangle, they've started widening the search, not for more ships or planes, but for data, wind behavior, electromagnetic spikes, ocean floor vibrations, atmospheric charges, strange anomalies in other parts of the world that mimic what we see here. Because oddly enough, similar incidents have been reported in other parts of the globe. They just haven't become legends yet. Take the Devil's Sea off the coast of Japan, known locally as the Dragon's Triangle. Much like the Bermuda Triangle, it's been linked to vanishing vessels, compass failures, and erratic weather. Japanese authorities have quietly logged dozens of unexplained incidents there, but it lacks the media attention, the myth making, the cultural weight. In both places, experienced crews reported instruments going haywire, calm waters that suddenly turned violent, ships vanishing between radio check ins with no distress call, no wreckage, no trace. That pattern repeats in the South Atlantic too, off the coast of Brazil, near the so called South Atlantic anomaly. Satellites regularly glitch, spacecraft sensors drop offline for seconds at a time when passing over this zone. It's a region where Earth's magnetic field is unusually weak, thinner, almost as if something presses from the other side. And that brings us back to the core idea. Maybe the Bermuda Triangle is not one place on Earth. Maybe it's the result of intersections. Intersections between ocean currents, magnetic irregularities, and atmospheric turbulence. Between plate tectonics, pressure pockets, and solar radiation. A rare alignment of invisible forces that, when combined, make certain regions temporarily unstable. In this theory, the triangle doesn't move so much as it appears where conditions align, and when they do, things go missing. Instruments lose their minds, people feel disoriented, navigation turns upside down. This would explain why some flights report bizarre phenomena just outside the accepted boundaries. Why disappearances stretch as far as the southern Atlantic, or curve back toward the Gulf of Mexico. The triangle, under this lens, isn't a boundary drawn with a ruler, it's a ripple, an effect, like a pressure wave, forming and fading as variables shift. Recently, researchers analyzing decades of satellite and aviation data have started looking for clusters, incidents of unexpected radar loss, deviation from flight paths, or sudden drops in altitude. When these incidents are plotted, some appear right inside the triangle, but others scatter across the globe. above certain volcanic ridges, along tectonic fault lines, and in places where deep ocean currents twist upward from the abyss. They're few, sporadic, easy to dismiss individually, but when viewed as a system, they begin to form a pattern. A group at the University of Copenhagen, working alongside an international team of geomagnetism researchers, released a quiet white paper in early 2025 proposing that these phenomena may be tied to a concept called geomagnetic flux variation. It's a complex term, but the idea is simple. Earth's magnetic field doesn't just have a north and south, it has pulses, surges, temporary distortions, like a wave in a pond caused by solar winds, iron movement in the core, or even deep sea pressure collapses. When these distortions spike in a localized area, they can scramble navigation tools, interfere with radio frequencies, and in extreme cases, disorient living creatures. Pilots, sailors, birds, whales. Some believe these fluxes might be responsible for the stories of compasses spinning, of time vanishing, of entire crews feeling dazed. It's not that they entered a cursed zone, they passed through a ripple, a temporary shift in the Earth's invisible skeleton, and maybe that's why no single explanation has ever fully satisfied the world, because we keep trying to explain a moving storm with a static map, a living pulse with dead coordinates. If this theory holds, it means we might not have a Bermuda Triangle at all. We might have dozens of them, active at different times, different intensities, across the world's oceans, moments when the conditions are just right or just wrong for something to go terribly off course. It doesn't mean aliens, it doesn't require wormholes, but it does suggest we've been asking the wrong question for almost a century. The question isn't, what's in the Bermuda Triangle? It's what combination of forces makes the triangle happen at all. And just as that thought begins to settle in, a more chilling possibility arises that something far bigger than coordinates is at play, and that our planet, in certain moments, in certain places, simply stops following the rules we thought we knew. The sea doesn't leave breadcrumbs. When a ship vanishes or a plane disappears without a signal, the ocean simply folds over, erasing every ripple like nothing ever happened. No trail, no sound, no goodbye, just absence. A silence that stretches wider than the sky above. And maybe that's why the Bermuda Triangle still haunts us, not because of what we know, but because of what we never find. In a world where satellites can read license plates from orbit and data flows faster than thought, the Triangle dares to say, "You don't know everything." It humbles us, because even after all the sonar scans, the flight recorders, the pressure readings, and magnetic charts, we still find ourselves with questions that refuse to settle. Why do some wrecks drift far outside expected currents? Why do compasses twist near nowhere in particular? Why do time gaps show up in pilot logs? Not every time, but just enough to keep the doubt alive. We've followed wreckage to the seafloor. We've measured electromagnetic pulses. We've dropped probes into trenches so deep they could swallow cities whole. And yet, for all our effort, the story remains slippery. There's no master key, no final answer waiting to be unlocked with the right formula. Just fragments. A ship found decades late. A radio signal cut mid-sentence. A pilot who felt something shift just before the world tilted. And in those gaps, our imaginations take over. For some, the mystery is purely scientific, a puzzle of currents and magnetic anomalies, of methane vents and sonic waves and invisible physics. For others, it's something older, something more primal, a sense that not all places are meant to be charted, that some corners of the earth still belong to legend. But maybe the most uncomfortable truth is this: we may not be supposed to know. Not because there's some forbidden knowledge buried under the waves, but because mystery itself has a purpose. It slows us down, it forces humility, It invites wonder. Without mystery, we become machines. With it, we become explorers. We need stories like this, stories with open endings and no easy conclusions, because they remind us how vast the world still is, how much remains unmeasured, how little of our oceans we've truly mapped, and how the moment we believe we've solved everything, the sea quietly reminds us we haven't. So maybe that's why the Bermuda Triangle persists, not as a conspiracy, not as a hoax, but as a mirror reflecting our need to believe that Earth still has secrets, that somewhere, beneath miles of water and silence, the unknown still breathes. And now, I'd love to know what you believe. Do you think there's a rational explanation for it all? Currents, fog, radar glitches, and chance? Or do you feel there's something deeper happening beneath the surface, something science hasn't touched yet? Scroll down, share your thoughts in the comments. What do you think is happening under the triangle? And if you've enjoyed drifting through this story, through science, mystery, and everything in between, I'd like to invite you to stay a little longer. Subscribe to the channel, not just for answers, but for better questions. Together, we'll keep exploring the edges of what we know and the shadows just beyond it, one dreamy story at a time. And who knows, maybe the next time you stare out across the sea or up into a cloudless sky, you'll feel it too. That whisper, that pause, that quiet reminder that the world is far more mysterious than we've ever been taught to believe. And maybe that's exactly how it's meant to be.